Hello students, my name is Brendan Hammond, a member of Parliament for Yukon. I'd like to commend you for your mountainous region that relies on the next generation of science to keep it that way. Wishing you all the best of luck, and most of all, have fun. Hello students, my name is Brendan Hammond, a member of Parliament for Yukon. I'd like to commend you for your
Hello, Mayor Bonnie Crombie here from the great city of Mississauga, sending my best wishes to all the participants, organizers, and contestants at the 14th Abdus Salam Science Fair. This event is a wonderful initiative that provides students in our community the opportunity to conduct research, think critically, discover new things, all while learning about science and, most importantly, having fun. I'd like to thank the organizers of this annual event for providing a platform. Hello, Mayor Bonnie, and I'd also like to thank the city of Mississauga for submitting their really best wishes to all participants. I hope that each of you has learned something new at the fort and takes the skills to this event is a wonderful initiative. I can't wait to see what you students in our community. Once again, congratulations to the winners of this year's Science Fair. Discovering have a wonderful event, all while learning about science and, most importantly, having fun. I'd like to thank the organizers of this annual event for
I'm Chandra Arya, Member of Parliament for Nepean. I would like to thank Nabil Rana, coordinator of the Science Fair, for inviting me to greet you today. While today's fair is virtual, as we look to the future beyond COVID-19, I am sure that the Abdus Salam Science Fair will be held in person once again. I would like to thank the parents, teachers, and school volunteers who have encouraged students' interest in science so far, as STEM skills will be very valuable in the knowledge-based economy of the future. The engineers, chemists, and biologists of the future may be amongst the participants today. To all those students who participated in this year's science fair, I hope you have taken the opportunity to explore the areas of science that are new to you and that you have enjoyed developing your project. If you have discovered an interest in science, I encourage you to pursue this in the future and to participate in next year's fair. I would also like to wish the Abdus Salam Science Fair many more years of encouraging students to take an interest in science. Thank you again.
Hi, Mayor John Taylor here of the town of Newmarket, and I would just like to take this opportunity to congratulate all of the participants in the 14th annual Abdus Salam Science Fair. This science fair is a great opportunity to engage the youth of our communities in the importance of science and learning. To all of the participants, congratulations on participating, and to the finalists, congratulations on being a finalist. All of your work and all of your learning will position us well as a community and as a society for the future that we know through COVID will rely more heavily on science for our safety and well-being. Enjoy the opportunity to learn, enjoy the competition, and most of all, thank you for participating. Thank you.
Good afternoon, everyone. Assalamu alaikum. My name is Rick Nichols. I'm the MPP for Chatham-Kent-Leamington, and it's my honor to have been invited to attend the award ceremony for the 14th annual Abdus Salam Science Fair. Now, I do know that it involves grades 5 to 12, but you know what excites me the most is that in this science fair, we have young, brilliant minds willing to put it on the line, as I call it, to prepare and present their creative ideas, their science fair ideas. And that's where great ideas are born from. Who knows? Maybe at some point in time down the road, one of our participants, doesn't necessarily have to be one of the winners, but one of the participants may in fact become a Nobel Peace Prize. Well, inshallah, that will happen, because I know that there's a lot of wonderful things going on within your community. You know, when it comes to awards, we can't all win, but what's more important is that you participated and you were willing to put it all on the line. Not everyone can, as I say, finish in first place, but that doesn't matter, because by the fact that you are prepared to present your findings and your creative ideas, to me, that makes you a winner already. So again, I want to thank everyone for their participation. Inshallah, we shall meet again. Again, thank you very much for the invitation, and look forward to hearing the results of your 14th Abdus Salam Science Fair. Shukran. Thank you very much.
Everyone, my name is David West, and I'm the mayor of Richmond Hill, Ontario. I'm delighted to have the opportunity to bring greetings to everyone participating in the Abdus Salam Science Fair of 2022. The Science Fair is a remarkable way for students from grade 5 to grade 12 across this country to demonstrate their ingenuity and imagination. Students who have a passion for science are one of the great hopes for our future. Whether you are interested in physics, chemistry, astronomy, or whatever branch of science you're keen on, your passion is an inspiration to us all. In an ever-evolving and fast-changing world, science is the thing that will help us solve some of the most challenging problems we are facing. We have seen the power of science lately as vaccines have been developed at a pace that was unheard of a few years ago. Scientific solutions will be critical to addressing the challenges of climate change. And when I see the enthusiasm and innovation that the Science Fair submissions reflect, I look forward to our future with a strong sense of optimism. I want to thank the organizers of the Abdus Salam Science Fair, and I want to wish all the best to all the contestants. And to the winners, a hearty congratulations.
Hello everyone, my name is Lindsay Matheson. I'm the Member of Parliament for London Fanshawe, and I wanted to congratulate all of the organizers and the participants of the Abdus Salam Science Fair. This is an incredible yearly event that really stretches young minds and celebrates science, celebrates math and technology and that advancement of learning that is so incredibly important. I am so grateful that this continues on, that it's continued on throughout all of the years that we've been dealing with COVID, and that we're really pushing young people to see how they can contribute and see what that discovery and that extension of learning can be. Thank you so much. I wish you all the very best and have a really great science fair. Take care.
Hi, my name is Jenny Kwan. I'm the Member of Parliament for Vancouver East, and I'm bringing this message to you from the unceded Coast Salish territories of the Musqueam, Squamish, and Tsleil-Waututh First Nations. I am so excited to join with all of you through Zoom today and to say congratulations to all the students for your participation in this very exciting science fair. It is a place where you can showcase your talent, your skills, your ingenuity, and your creativity. It is a place to meet with peers in your community and to share with each other the wonderful ideas that you have. I wish all of you all the very best in this science fair, and may your science project be the leading edge of tomorrow for better science for our community and for a better future. Congratulations to everyone. And a big thank you also to all the organizers and the volunteers behind the scenes in bringing together this wonderful event for the young people today.
On behalf of the City of London and my colleagues on City Council, it is a genuine pleasure to join you for the 14th Annual Abdus Salam Science Fair's Awards Ceremony. Look, as some of you may know, during my time as a Member of Parliament in Ottawa, I served 2 years as Minister of Science and Technology. And it gave me immense pride then and immense pride still to see young people working hard while exhibiting their skills, ideas, aspirations through the wonder of science. As Minister, I lived by 2 mantras: be curious and be bold. Well, today we are here because of you. Not only do you represent the best of our future, you provide inspiration to all of us. You do that through your creativity, your curiosity, and your persistence. At a time when such traits are not always obvious, let me say thanks. Thanks for proving otherwise. Let me also acknowledge your parents and teachers and friends for their support to you. We all know how much that kind of encouragement truly means. So to everyone here, let me wish you nothing but the best on this day. It's special. I always said there are 2 things to consider to be successful: persistence and determination. So I look forward to watching how you shape and improve our world in the future with persistence and determination. Thank you.
Hello, I'm Mayor Frank Scarpitti from the city of Markham, and on behalf of Abdus Salam Science Fair, I'd like to welcome all of you to the 14th Annual Awards Ceremony. It's a pleasure to be here once again with all of you. It's wonderful that a national science fair named after the Nobel laureate Dr. Abdus Salam can provide a platform for students right across Canada to be creative and engage in scientific thinking while showcasing their skills and their bright ideas. Our youth are eager, enthusiastic, creative, and curious. Our future needs young talent and bright minds. They are our next generation of innovative leaders. Congratulations to all the award winners for your exceptional work. A special thank you to the Committee of Abdus Salam Science Fair for continuing to inspire young minds and foster a greater curiosity in science. As the Mayor of Markham, I'm very proud of all of you. Congratulations.
Hello, this is Sean Chen, Member of Parliament for Scarborough North, and I'm so delighted to bring greetings on this wonderful occasion of the 14th Abdus Salam Science Fair. This is a wonderful opportunity for young Canadians in grades 5 through 12 from across the country to gather, to learn, to engage in science, and to put their talents to the test. They have worked hard over the past months to develop their science projects, and I know that through this process they have learned, they have grown, and they are ready to showcase their incredible work. I congratulate the students, to all the participants, to the teachers and the mentors and volunteers for your incredible initiative, and I wish all the young people much success in their work. I know that by learning science, you will contribute to not only your learning, but eventually contribute to the betterment of society and the world. Congratulations once again, and I wish you all a most successful event. Thank you.
Mayor Mike Savage of the Halifax Regional Municipality, and I wanted to stop in today to welcome you all to the 2022 virtual Abdus Salam Science Fair Awards Ceremony. You've all worked very hard to get here. Well done to all the emerging young scientists here today. We need you. This project is a great way to learn from each other, to challenge each other, and of course, to have fun while you're doing it. So congratulations to the award recipients. Best wishes, Mike Savage.
Hello, I am Salma Zahid, your Member of Parliament for Scarborough Centre. Thank you very much for the opportunity to extend my warmest greetings to all of you during the 14th Abdus Salam Science Fair Award Ceremony. The National Science Fair commemorates the achievements of one of Pakistan's most celebrated scientists, the Nobel Prize winner, Dr. Abdus Salam. I'm very excited about your efforts because you engage and encourage young people to develop scientific thinking and become involved in the sciences. And of course, you also make science fair. Indeed, it is one of our federal government's leading concern to develop our capacity in science and innovation. Science powers the development of our nation, the improvement of our lives, the growth of business, and of course, our economy. Science helps us better understand our world and find ways to protect nature and the health of our citizens. And in the last 2 years, that Canada and the rest of the world has been impacted by COVID-19. Science is one of our strongest weapons in the fight against pandemic. I want to congratulate the organizers and the participants of Abdus Salam Science Fair. And to the youth, I would like to say, keep on moving forward. Continue to build your skills, knowledge, and understanding of this world. You are the future of Canada.
I'm pleased to extend greetings to everyone attending the 14th Abdus Salam Science Fair Virtual Award Ceremony. Congratulations to all the nominees and award recipients. Today's event is an excellent opportunity for students to showcase their skills, creativity, and ideas in the field of science and technology. Learning and discovery are part of a lifelong journey that opens the doors to endless possibilities. I want to thank the event organizers for providing a virtual platform for youth to display their work, stay connected with their peers, and manifest their greatest aspirations. Our future looks bright because of young leaders like you.
My name is Talib Nur Muhammad. I'm the Member of Parliament for Vancouver Granville, and I just wanted to congratulate all of the participants in the Abdus Salam Science Fair for the work that you're doing and for all of your incredible projects that I know you're putting together. You know, there's a long history of innovation in science from the Muslim world dating back to the earliest days of Islam. And living those values and living that passion for science is something that I know all of you that are participating in this science fair believe in. And so as you think about the work that you're doing as emerging as budding scientists and the transition into university and ongoing from here, you're going to make a huge difference in innovation and building a better planet. So congratulations to all of you, and I wish you all the success.
Hello, I'm Don Mitchell, Mayor of the town of Whitby. On behalf of the members of council, thank you for inviting me to speak virtually at the 14th annual Abdus Salam Science Fair Awards ceremony. This is a great opportunity for children to experience, discover, and have fun with the exciting world of science and technology. As the Mayor of Whitby, I would like to thank all of the organizers, and of course, first and foremost, the students for submitting their projects. You know, scientific literacy is more important now than ever, so we all need to encourage our students to get involved, and we need to promote the importance of learning science, and participating in a science fair is a great way to do that. So a big well done to everyone, and enjoy the ceremony.
Hello, everyone. My name is Kirsty Duncan, and I'm the Member of Parliament for Etobicoke North. But before I ever served in Parliament, I was a scientist. I led an expedition to the Arctic and I studied and researched climate change and global pandemics. I would like to thank all the organizers for putting on this science fair, and I would also like to thank teachers and parents for teaching, caring, and inspiring our wonderful youth, and for seeing what is special in each child. And congratulations to every amazing student who chose to take part in the science fair. It takes real courage and an enormous amount of work. I wish I could have met all of you and heard about each of your wonderful projects. I want you to know that I am very proud of all of you, and I hope you will keep being curious and asking questions. In fact, I have a few questions for you to think about. Why do you dream? What's at the bottom of the ocean? Can you bring back the dinosaurs? And do you think animals can talk? A few thoughts to get you thinking. Fish make sounds like boops and honks, and Coco the gorilla used sign language. I love science, and I hope you do too. So keep discovering, keep exploring, and I can't wait to see what you accomplish next. Congratulations, everyone. I'm cheering you on.
Hello, everyone. On behalf of the Honourable Premier Jason Kenney and my colleagues in the Alberta Government, I am so very pleased to welcome and congratulate all participants of the 14th Annual Abdus Salam Science Fair. It is so great to see children and youth experience, discover, and have fun, as well as really experience a sense of accomplishment with science and technology. And it's clear that there has been a lot of work that has gone into these amazing and inspirational projects. Your curious minds, thirst for knowledge, and great efforts show that Canada's future is in such bright and promising hands. Thank you for sharing your innovative ideas with others right across this country. As you progress through school and beyond, I really strongly encourage you to keep exploring, asking questions, and finding answers. Thank you also to the parents, to teachers and mentors who have helped inspire and nurture the many projects presented here today. And to the educational leaders and event organizers who have worked very diligently to make this fair a success, I want to issue you a huge thank you as well. Your support is instrumental in helping Canada's youth become the researchers, innovators, and scientists of tomorrow, and that cannot be understated. Once again, congratulations to this year's award recipients, and thank you to everyone who has participated. I wish you continued success in all of your future endeavors.
On behalf of the entire government of Manitoba, I'd like to congratulate all of the students who participated in the 14th Annual Abdus Salam Science Fair. Abdus Salam was a Pakistani theoretical physicist and the first person from an Islamic country to receive the Nobel Prize in Physics. He made extraordinary contributions to his country and showed incredible dedication to scientific inquiry throughout his life and his career. You are honoring his legacy by developing hypotheses, testing, evidence, and submitting your findings for scrutiny. You are learning how to engage in the scientific method that has created some of the greatest achievements in human history. You are also helping us build a future we can all be proud of. I want to congratulate the finalists and all the students who participated in the Abdus Salam Science Fair throughout Manitoba. I hope you will maintain your curiosity and dedication to the scientific method for many years to come. To all the students, good luck and have fun.
Good afternoon. Bonjour. Assalamu alaikum. Thank you for including me in the Abdus Salam Science Fair. Même si je ne peux pas être avec vous aujourd'hui, je tenais à vous adresser la parole. Although I could not be with you today, I wanted to share this message with you. I applaud you for participating in the science fair created in honor of Dr. Abdus Salam, the first Muslim Nobel laureate. Taking part in a science fair gives us the opportunity to acquire new knowledge and to develop an interest in research. I encourage you to continue to question yourself and to find answers to those questions through science. I would like to congratulate all the participants in this event. I am sure you will come away with new ideas that will serve you for years to come. I also congratulate the winners of all 4 categories. You have impressed the judges with your projects, and you should be very proud of yourselves. Je vous remercie de votre invitation et je vous souhaite une excellente remise de prix aujourd'hui. I thank you for your invitation and I wish you a great awards ceremony. Good luck to everyone. Bonne chance.
Have you ever wondered about the interactions that control the universe? Have you ever thought about the story of the 4 fundamental forces: gravity, strong force, weak force, and electromagnetism? From stopping us flying into space to providing visible light so we can see, they can be found all around us. Physicists believe that the 4 forces were once unified, but then separated with the expansion of the universe. In fact, in 1979, Professor Abdus Salam was awarded the Nobel Prize in Physics, alongside 2 American physicists, for their revolutionizing work in the field of electroweak unification. So, what exactly does this discovery mean? Well, Professor Abdus Salam successfully showed how electromagnetism is in fact connected to the weak force. He hypothesized that the existence of a neutral particle is fundamental to carry the weak force, and so, to find the W and Z boson particles, the grand unification theory was coined. This theory even formed the bedrock for the discovery of the Higgs boson particle in 2012. So, let's explore the life story of Professor Abdus Salam. He was born in 1926 in a remote province of Punjab, Pakistan. In 1964, he came to the UK on a scholarship and studied at the University of Cambridge, completing his PhD in theoretical physics. Whilst at Cambridge, he was awarded the Smith Prize for pre-doctoral contributions to physics. In 1957, he became Professor of Applied Mathematics at Imperial and also co-founded the Theoretical Physics Department. He also founded the United Nations International Centre for Theoretical Physics in Trieste, Italy, to provide an international forum to the scientists from the underrepresented countries to share their ideas and theories. Professor Abdus Salam was a man who broke all barriers to rise as the first Muslim Nobel laureate in science. And so we remember him as the man who proved that knowledge knows no limits and that scientific thought and its creation is the common and shared heritage of mankind.
I think respected Amir Saab is with us, so we should seek his permission to start the program at 2:30.
Ji Amir Saab, if you give us the permission, we can start the live
Assalamualaikum.
program. Walaikum assalam.
Assalamualaikum warahmatullah. Please start the program.
Good afternoon, viewers. We are live now. We, on behalf of the Education Department of the Ahmadiyya Muslim Jamaat of Canada, a very warm welcome to everyone joining us from throughout Canada or from around the world. My name is Nabil Rana, and I will be your host for today for its very exciting award ceremony of the 14th Abdus Salam Science Fair. I will be joined by the Science Fair Chair, Dr. Hamid Mirza, for the announcement of awards. On the technical side, I will be assisted by Shahid Mirza Sahib. First, I have an acknowledgement to make from coast to coast for the ancestral and unceded territory of all the Inuit, Metis, and the First Nations people that call this land home. As it is customary, we will begin with the recitation from the Holy Quran. I invite Faraz Chaudhry to recite a few verses from the Holy Quran, and then Asfar Anjum will present the English translation.
Assalamu alaikum wa rahmatullah. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. هو الذي أنزل من السماء ماء لكم منه شراب ومنه شجر فيه تسيمون ينبت لكم به الزرع والزيتون والنخيل والأعناب ومن كل الثمرات إن في ذلك لآية لقوم يتفكرون وسخر لكم الليل والنهار والشمس والقمر والنجوم مسخرات بأمره إن في ذلك لآيات لقوم يعقلون وما ذرأ لكم في الأرض مختلفا ألوانه إن في ذلك لآية لقوم يذكرون وهو الذي سخر البحر لتأكلوا منه لحما طريا وتستخرجوا منه حلية تلبسونها وترى الفلك مواخر مواخر فيه ولتبتغوا من فضله ولعلكم تشكرون وألقى في الأرض رواسي أن تميد بكم وأنهارا وسبلا لعلكم تهتدون وعلامات وبالنجم هم يهتدون جزاك الله.
We can have Asfar Anjum to present the English translation.
Assalamu alaikum wa rahmatullahi wa barakatuh. I will now present the English translation of the verses just recited from Surah An-Nahl, verses 11 to 17, by Hazrat Maulvi Sher Ali Sahib, Raziyallahu Ta'ala Anhu. I seek refuge with Allah from Satan the rejected, in the name of Allah, the gracious, the merciful. He it is who sends down water for you from the clouds. Out of it you have your drink, and there grow from it trees on which you pasture your cattle. Therewith he grows corn for you, and the olive, and the date palm, and the grapes, and all kinds of fruits. Surely in that is a sign for a people who reflect. And he has pressed into service for you the night and the day, and the sun and the moon, and the stars too have been pressed into service by his command. Surely in that are signs for a people who make use of their reason. And he has pressed into service the things he has created for you in the earth, varying in colors. Surely in that is a sign for a people who take heed. And he it is who has subjected to you the sea, that you may eat therefrom fresh flesh, and may take forth therefrom ornaments which you wear. And thou seest the ships plowing through it, that you may thereby journey, and that you may seek of his bounty, and that you may be grateful. And he has placed in the earth firm mountains, lest it quake with you, and rivers and roots, that you may take the right way. And other marks too, by them and by the stars, they follow the right direction. Jazakallah.
Thank you very much, Faraz and Asfar. We will have some introduction to the science fair by Dr. Amir Minhas Khan, the coordinator of this science fair. Dr. Amir, please go ahead.
Thank you very much, Nabil sir. Respected guests, participants, and parents, Assalamu alaikum wa rahmatullahi wa barakatuhu. My name is Amir Minhas Khan, and I am coordinator of Abdus Salam Science Fair. You all are welcome in virtual award distribution ceremony of 14th Abdus Salam Science Fair. Due to COVID-19, we are holding this program virtually once again. In the memory of an Ahmadiyya Muslim Nobel Laureate, Dr. Abdus Salam's contribution to science, Talim Department of Ahmadiyya Muslim Jamaat Canada holds this program every year. This year, once again, students were requested to prepare their projects registered at abdussalamsciencefair.com website and submit their 5-minute project videos. I'm very pleased to share with you that by the grace of Allah, despite all restrictions, we have received 108 project videos from whole Canada. Today, we will announce winners' names, but actually all participants of the science fair are winners because despite all of the hurdles, these participants stepped forward and took part in the fair. I congratulate you all because this courage of taking part in a competition will remain with you even after the fair and will bring many other successes in your academic life. I like to congratulate all the parents who supported their children during the process, because your support is very essential for the success of your children as well as this science fair. And I believe you will keep supporting your children in other competitions of their life thereafter, because who knows, one day your child compete Nobel Prize race. It was Dr. Salam's parents' support and prayers that brought a great success of Nobel Prize in Dr. Salam's life, who belongs to a very poor family, poor background. I assure you that your children feel your support very deeply and make their future decisions based on that support. Once promised Messiah Hazrat Mirza Ghulam Ahmad Qadiani alayhi salam was complained by the teacher about the bad class performance of one of his son. So that son, Hazrat Mirza Bashiruddin Mahmud Raziyallahu Ta'ala anhu, second Khalif of Ahmadiyya Muslim Jamaat, narrates himself. My father replied to my teacher that my son is very sick and I am very worried about his health. This incident shows how much Hazur alayhi salam take care of his children and how deeply Hazur alayhi salam's children feel the pain of their father. This year we have received 108 videos in 4 categories called Abu Ali Sina for grade 5 to 8 girls, Jabar Ibn Hayyan grade 9 to 12 girls, Al-Khwarizmi grade 5 to 8 boys, Ibn al-Haytham grades 9 to 12 boys. There were 2 phases of judgment and 5 judges judged final winners project during these phases. In the end, I like to take the opportunity and thanks my team members who supported this science fair. Thank you so much. Jazakallah.
Thank you, Asim. We will now proceed to the first session where Dr. Hamid Mirza Saab will announce the winners of the first group, that is the girls grade 5 to 8. So Dr. Saab, you can proceed now.
Assalamu alaikum wa rahmatullahi wa barakatuhu. It is my great pleasure to announce the finalists, those who win the competition in science fair. In grade 5 to 8 girls category, the third prize winner is Shaista Nadeem Saiba. She has the project named Can Coverings Over Plants Differ Plant Growth? So we will play the video and we'll watch how she has shown this.
Assalamu alaikum wa rahmatullahi wa barakatuhu. My name is Shaista Nadeem and I am 13 years old. I am from the Durham Jamaat and today we will ponder over this question. Can coverings over plants defer plant growth? My hypothesis. Glass absorbs light and styrofoam absorbs light very slowly. So to test this theory, we will plant marigold seeds to see if they each absorb more sunlight and grow larger. We will have a glass case over one of the pots to test whether the seed grows faster. We will use a styrofoam case over a different pot to see if it grows slower. And to determine the differences between the two, we will have seeds growing into other pots too as the controls. The materials you will need for this experiment are seeds of some type, 4 normal pots or cups, a glass case, a styrofoam case, soil, or a good replacement are cotton balls, gloves, water, sunlight or a window, and an adult to help if you need it. Now let's move on to our experimental procedure. This first pot will be the plant that is covered in glass. The second pot will be control number 1. This pot is the one that's control number 2. And this last pot will be covered in styrofoam. Step 1. Fill up each cup with soil. Step 2. Make a small hole in the middle of each pot and add seeds. Step 3. Cover up the holes with more soil if you'd like. Step 4. Give your plants a little bit of water. Now let's check how our plants are throughout the next couple of days. These are the plants 2 days later. On day 5, they each grew a little bit, except for control number 1. And day 10, they all had grown at least a little bit. This is control number 1's final result. This is control number 2's final result. This is the styrofoam-covered plant's final result. And last but not least, this is the glass-covered plant's final result. Data analysis. Control number 1 had a little bit of trouble growing, but it did end up sprouting a little. It is by far the smallest plant. Control number 2 grew pretty close to the styrofoam-covered plant, which grew pretty tall considering it was covered. They are both the second tallest plants. The glass plant got some fungi, but it still grew the fastest and the tallest. Conclusions. So as you saw, my hypothesis was partly correct. The glass-covered plant did grow the fastest and tallest, but the 2 controls grew the slowest. If anything, the styrofoam made the plant grow a little bit faster. This is also similar to what happens in a greenhouse. The glass keeps in moisture, heat, and light, helping the plant grow. This is also the reason why my glass plant had fungi develop. These were my results, but you may have different results depending on how you grew your plants.
Excellent project.
If you want, you could plant different seeds to see whether this is the same results with other seeds or just marigold seeds. You could also test to see if this experiment would work with other types of cases, such as aluminum, wood, or stone. Resources.
MashaAllah, excellent work by Shaista Nadeem. I hope she will be studying more on the agriculture in future. We need more scientists. The second prize winner is Aiza Shahzad Saiba. She has the project, it's called The Science Behind Tsunamis. So let's see how tsunamis work.
Bismillahirrahmanirrahim. My name is Aiza Shahzad and I'm in grade 7 and the topic of my presentation is the science behind tsunamis. What is a tsunami and how does it form? A tsunami, the Japanese word meaning a harbor wave, is a series of long waves caused by a large sudden displacement of the ocean, usually the result of an underwater earthquake, volcanic eruption, landslide, explosion, the collapse of rocks, glaciers, or even asteroids impacting the water. This force creates waves that radiate outwards in all directions away from the source, sometimes crossing entire ocean basins. Here are a few diagrams of how tsunamis can occur. The first one shows how a tsunami is made by a volcanic eruption. The second one shows how a tsunami is made by an asteroid impact. The third one shows how a tsunami is made by erosion. And the last and most common one shows how a tsunami is made by an earthquake. What causes tsunami waves to decrease velocity as they move towards the shoreline? Well, when the tsunami reaches shallow water, wave shoaling occurs. Because there is less water to move through, this massive amount of energy is compressed. Then the wave speed slows down while its height rises to as much as 100 feet, creating the destructive tsunami. The objective of this demonstration is to investigate and model the effect that water depth has on wave velocity. I hypothesize that the velocity of tsunami waves will depend on water depth. As the water depth increases, the wave velocity will increase as well. The materials you will need for this experiment are a water tank or a plastic container, some water, a piece of wood, a permanent marker, a stopwatch, a ruler, a lab notebook, a volunteer, and some food coloring. Now here's the procedure for my experiment. The first step is to move any items away from the place at which you will be testing that could be damaged by water, as there might be a little splashing caused by the water. Place the water tank on a white or light colored surface. This will let you see the waves clearly. I also added some food coloring for the same purpose. The next step is to fill the water tank until you have 1 centimeter of water in the tank. Use a ruler for accuracy. Create a data table in your lab notebook, like the one I have created below. Have your volunteer ready with the stopwatch to start timing how long it takes a wave to travel from one end of the tank to the other. Hold the bottom of the wooden block that is at least a few centimeters above the water. As soon as you drop the block and a wave is created, the volunteer should start the stopwatch. The volunteer should stop the stopwatch when the wave hits the other end of the tank. Record the time in the data table in your lab notebook. Now, fill the water tank until the water depth is 2 centimeters. Use the ruler to confirm the water depth. Try to drop the block the same way you dropped it before each time. Record all the data in the data table in your lab notebook. Now, fill the water tank until the water depth is 3 centimeters. Use the ruler to confirm the water depth. Record all the data in the data table in your lab notebook. Lastly, empty the tank and repeat steps 4 to 7 2 more times so that you have a total of 3 trials for each depth. Be sure to record all the data in the data table in your lab notebook. Now here is a video of me dropping the wooden block into the water. The wooden block represents an asteroid falling from above, and the water represents the ocean. It's time to analyze my data. Here are the results of my experiment. I have also created an equation based on my experiment. This equation shows the mathematical relationship between the wave velocity in shallow water as a function of water depth. And it states that velocity is the square root of the product of the acceleration of gravity and water depth. Conclusion: I predicted that the wave velocity would increase as the depth of the water got deeper. As you previously saw from the results of my experiment, my hypothesis was correct. Therefore, the speed of a tsunami depends on the depth of the water it is traveling through. The deeper the water, the faster the tsunami. As a result, in the deep ocean, tsunamis can move as fast as a jet plane over 500 miles per hour and can cross entire oceans in less than a day. Thank you for listening to my presentation. Jazakallah.
MashaAllah, very good experiment. Now, our first prize winner in this category is Aliza Maruz Hadi. She has made saltwater fuel cell. So let's see how this fuel cell works.
Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. My name is Aliza Maris Hadi, and the topic of my science fair project is a saltwater fuel cell. I found a very interesting toy that was powered by salt water. At first, I did not think it would work. How could salt generate electricity? But when I tried it, it worked. I thought this could solve a lot of the world's energy problems because the oceans are made of salt water and they are very big. We could get an unlimited amount of energy without polluting the environment. Then I wanted to understand how it worked. I wanted to see if I could make the fuel cell generate more electricity and make the car go faster. Since the car worked by adding a salt solution, I thought by increasing the concentration of salt in the water, I will be able to increase the voltage and amps generated from the fuel cell to make my car go faster. I designed an experiment where I would measure the voltage and amps generated by the fuel cell at different salt solution concentrations. On the right, you can see my experimental setup. This slide shows the materials needed to do the experiment. Some of the key things you need are salt, water, multimeter, and a magnesium plate. First, measure 100 milliliters of tap water into 13 different cups. Label each glass with the percentage of salt that will be added to it. Using a measuring scale, weigh the different amount of salt to be added to each glass. Stir the solution until the salt has dissolved as much as possible. Measure the temperature of the water. Attach the negative lead to the magnesium plate and the positive lead to the cathode. Place the magnesium plate and the cathode into the salt solution and measure your volts and amps. Record your observations. But first I needed to understand how many grams of salt 100 milliliters of water could hold. I did some research and found that approximately 35 grams of salt can be dissolved in 100 milliliters of water at 20 degrees Celsius. This is shown by the graph on the right. I used this information to find the different amounts of salt that I needed to add, where 35 grams equaled 100% concentration. During the experiment, I observed many interesting things. I noted that as the concentration increased, the solution got cloudier. And in the 100% concentration, there was still some undissolved salt at the bottom. And in the 80 and 60% concentration, there was still some undissolved salt, but it was much less than the 100% concentration. And only a few grains were in the 60% concentration. When the magnesium plate was in the salt solution, bubbles were observed coming out of the plate. After the experiment was complete, the magnesium plate was much thinner than before and had small dents on it and was a darker color. There were very few bubbles in the distilled water, and the amount of bubbles increased as the concentration increased. There was a cloudy substance observed in the water after the test was complete in the higher concentration solutions. The data I collected is shown on this table. I made a graph of the results to see if I could find a pattern. To my surprise, the voltage did not change with the concentration. Only small changes were observed. However, the milliamps increased with concentration. From the graph, you can see that the milliamps increased fast in the beginning at the lower concentrations, but then increased very slowly after 25% concentration, making a curved graph. At the start of the experiment, I had predicted that both voltage and amps would increase. However, this was not the case, and only the amps increased with concentration, proving part of my hypothesis to be correct. After 20 to 25% concentration, the benefit of increasing the salt concentration was very little. Based on the results, I would select a concentration in the range of 20 to 25% for my car. Out of curiosity, I increased the temperature of the 20% salt solution by heating it in the microwave. to see what would happen. I noticed with the higher temperature, the voltage remained the same, but the milliamps again increased. However, I need to do more tests at different temperatures to be sure. Something else I could try to increase the voltage might be increase the size of the plates and also try to use different types of salts. Jazakumullah. Thank you for listening to my presentation.
Thank you very much. It is a very interesting experiment. Actually, you are on the right track. Okay. In addition to these three winners, we have two consolation prizes. One will be going to Afia Nadeem Saiba. She has a project which was on winter wonders. Why does salt melt ice? And the second consolation prize will go to Samreen Khurram Saiba. She has a project called buoyancy, density, and homemade lava lamps. So inshallah, they will get those prizes after this conclusion of the ceremony. Jazakallah, back to Nabil.
Yes. So before we move to the next session, which is boys grade 5 to 8, which is Al-Khwarizmi group, we have a few honorable guests that I would like to introduce who are going to encourage what they saw or what they will be seeing later on. So first I will introduce Honorable Astronaut Mark Garneau. We are so much delighted to have him here today. He is an astronaut and a longtime community leader and has served the community as a member of parliament since 2008 as well. He is an electrical engineer from Empirical College of Science and Technology with a doctorate degree and has attended Canadian Forces Command and Staff College in Toronto, and Mark has served this country his entire professional career, beginning with the Royal Canadian Navy, where he worked as a combat systems engineer aboard the Algonquin in 1974. He was later promoted to commander and naval captain before retiring from the Navy in 1989. He made history in 1984 by becoming the first Canadian astronaut to fly in space as a payload scientist. In 1989, he was named the deputy director of the Canadian Astronaut Program. So it is my pleasure to invite him to say a few words to encourage the scientists who may want to become astronauts or want to pursue other fields like you have done.
Well, thank you very much, Nabil, and it's a real pleasure to be with you here today for the 14th Abdus Salam Science Fair and to participate in the Abu Ali Sina segment of the program. I've just watched, like everyone, 3 very impressive young women who have demonstrated some very rigorous scientific discipline in their particular experiments. And I also want to point out that delighted to be with my colleague from Parliament, Samir Zuberi, who I see is joining us today. I have to say that as a young person, I was always curious and I wanted to understand how things worked. I wanted to understand, for example, how a motor in an automobile, in a car, could make the wheels turn. And I wanted to understand how a cow could produce delicious milk just from eating grass. And I wanted to understand how we could get delicious apples or other fruit on trees when the tree just sort of took minerals out of the ground and of course water from rain and sunshine, and how did it produce beautiful fruit. And so I discovered as I was growing up that science was the way to try to understand what was around us. And it is, in my opinion, the key to helping us in the future. We've seen with COVID-19 that scientists worked very, very quickly and came up with a vaccine. It is because of scientists that we are beginning to manage this very serious virus. We have some more challenges in front of us with climate change, and we are hoping that scientists, such as the brilliant young women who have just demonstrated their scientific experiments, are going to help us to meet those challenges. So I congratulate all of the participants and the winners, and I look forward to participating in the question period a little bit later on. Thank you very much, Nabil.
Thank you, Mark. Yes, so will have a panel QA session, and a few of our esteemed scientists and panelists will be there. If anybody wants to, all the students who are watching or anybody from the audience who is watching wants to ask a question to any of the panelists, they can submit their questions at the website. There is a button to submit your questions. And if your question is selected by the chair, you will receive an email to join this meeting so that you can ask your question yourself and directly interact with these wonderful, wonderful scientists. So we will take one more guest before we move to the next segment, and that is Sumir Zuberi, who is an MP, member of Parliament from Quebec. Sumir Zuberi was first elected as the member of Parliament in 2019. He is currently the member of the Standing Committee on Justice and Human Rights and the Standing Committee on the Scrutiny of Regulations. Born and raised in Montreal, Samir has worked to build bridges between communities and to promote dialogue and mutual understanding from a very young age. This has led him to be at the forefront of protecting the charter rights of Canadian minorities and to working to promote diversity and inclusion, human rights, and mutual respect between all communities within Canada. Samir has also worked at the McGill University's Faculty of Medicine before joining into politics. So without much further ado, I invite Samir to say a few words encouraging our students.
Thank you, Nabil. And what a spectacular presentation from so many young learners. That was really fantastic. And you should all be so proud to share the knowledge that you have gained, but also just to be involved in this competition, to that rigor, that understanding. And I'm sure your parents are extremely proud of you for showcasing your work in front of. And I went to the live stream. 200 people who are tuning in live right now have seen and benefited from your presentation. And to add to that, we have right now Canada's first astronaut, the first Canadian who went to space, the Honorable Mark Garneau, who has been contributing to our society in so many different ways, from science to being an astronaut, to also and being a minister in a handful of portfolios that are critical to our society. And I hope that people do stay and benefit from that Q&A. As was mentioned before, doing what I do today, I was working at McGill in the Faculty of Medicine, helping young learners enter into the faculty, into different subjects such as nursing, medicine, physical therapy, occupational therapy, speech language pathology. And one thing that was key was a curiosity of learners to develop and to grow. And that starts at the tender ages of those of you who are presenting right now, those of you who are presenting here and tuning in. It's at this stage of your life that some key things are happening, where you start going into advanced courses and doors stay open for you. So if in the future you want to become an engineer, an astronaut, a physician, any professional within your field at the height of your level, like Ibn Sina, who's also known in the West as Averroes, who was a luminary physician, born in 980 after death, in the Muslim world at that time, to Mark Garneau. If you wanna be one of those luminaries of our society, doing what you're doing today is key. So congratulations to everybody who did present today, who will be presenting, and who competed, and to your families. Thank you, Nabil.
Thank you so much. Thank you. Now we will move into the next session, which is the Al-Khwarizmi group of boys 5 to 8. We have a few more guests, but I think that we will take them in the next session. So Dr. Hamid Mirza Saib, back to you to introduce the winners of the Al-Khwarizmi group.
Thank you, Nabil. Again, in this group, there was a significant competition, and it was difficult to choose the winners. However, we had to choose those top 3 position holders. So the 3rd position was earned by Abshar Ahmed. His project is wireless electrical machine. So we'll see now how he has developed those machines.
My name is Abshar Ahmed, and for this year's Abdus Salam Science Fair, I built a wireless electrical machine. I'm in the 7th grade, and I go to Robert H. Law Request. Mubarak Mosque is my majlis. First, I'll start by presenting all of the elements I used. Next, I'll define my project, then move on to my hypothesis, and finally, I'll show how I constructed my project and its importance. At last, I'll summarize my findings and present my conclusions. I used a fluorescent light bulb, a 2222N transistor, a 22 kilo ohms resistor, a 28 gauge copper wire, PVC pipe, LED, connector wires, and a 9-volt battery. My project is a wireless electrical machine, which is an energy source that can power vehicles, devices, and a lot more without connection. This device can be an excellent reusable energy source that can benefit us and make us progress in society. It will be powered by a 9-volt battery and will connect to a coil that will wirelessly light up our light bulb. The scientific concept used in this project would be electrical energy. Electrical energy is produced by the passage of electrons from one atom to another. Using this concept, I made a wireless electrical machine. This piece here is called a breadboard. It has tiny holes that you could connect electrical components to without soldering them. The first element inserted in the breadboard is a 2222N transistor. There are 3 pegs on the transistor: the emitter, the base, and the collector. The LED is a small bulb that lights up when electricity goes through it. The 22 kilo ohms resistor is a crucial aspect of this creation as well, as it lights up the LED and connects the battery source to the LED. Connector wires play a big role in this creation too, because they connect the breadboard to the main coil. My hypothesis for this project is that bringing a device, in our case a light bulb, close to the coil will cause it to light up, but it will have very short range and will not be able to light from a distance. First, begin by wrapping a 28 gauge copper wire outside of a PVC pipe. It can be 8 to 10 inches and there should be no gap between the copper and the PVC pipe. I'll then connect the 2222N transistor to our breadboard and connect the LED to the transistor's base. The resistor will be connected to the transistor's base, and the positive end of the LED will be connected to the transistor's emitter. The secondary coils and the coil will then be connected to the breadboard. When you bring your light source close to the coil, it shall light up. The existence of this creation is essential because it demonstrates how society can pay back the environment after all of the damage humans have done in this current day and age. All around us, we see destruction and various examples of how mankind has in a way impacted nature negatively. One of those factors include non-renewable energy. The major effect of this being the production of greenhouse gases that in turn causes climate change. Therefore, We can use this project as a way to move from non-renewable energy sources like coal and fuel and towards a more reliable and efficient resource like electricity. Electricity has recently been converted in some autos, trains, and buses. This end of war is a step towards a brighter future, allowing for easier production and lower costs. My results were that my hypothesis was correct. The bulb was not able to light up from a distance, and it was necessary to get closer for it to light up. Therefore, proving the limitation of the technology was your short range. In my experiment, I figured that the bulb will at least have to be 2 inches close to the coil. My conclusion is everything that I learned after I completed this project. There are pros and cons to every creation. Although this wireless electrical machine was successful and was able to complete it, there's a flaw, which was its reliance on short range. In the current day and age, this device is used to power cars, devices, and various other objects. Better tools and mechanics would have allowed more range and power. This beneficial invention could be an answer to help support the environment and create a sustainable future for us. Jazakallah.
MashaAllah, very good project. It was a very nice demonstration, and I hope you'll be able to do a better project where distance can be increased in future. That is the future. The second prize winner is Faris Shiraz. He has his project. It's called magnetic levitational train, maglev train. So let's see how this train works.
Assalamu alaikum everyone. My name is Farah Shiraz and I am from Calgary. I am in grade 5 and I study at Ahmadiyya Muslim School. Today, my project for Abdus Salam Science Fair is about maglev train. Maglev is a short form of magnetic levitation. Maglev trains are a very fast type of high-speed rails. They produce no air pollution because no fuel is being burned, so they are environment friendly. Maglev trains cover a distance of 30.5 kilometers in 8 minutes. That is a trip from Vancouver to Toronto in 3 hours. Magnetic levitation is technology that uses magnetic fields to make train move. The highest known speed of maglev train is 603 km per hour. The purpose of my project is to learn about how the maglev train works. When you put a magnet North Pole and North Pole together and try to make it float, it will fall and not float as the magnets will push the other pole away. But what about adding sport and weight? Will it float? My hypothesis is that it will be able to float with the help of weight and support. When you have North Pole and South Pole together, they will attract. But if you have North Pole and North Pole or South Pole and South Pole, they will not attract each other. So when you have North Pole and North Pole, they won't attract, and that is floating. But it will need sport to do. How does maglev train works? In maglev train, levitation works when the same magnetic poles repel and push the train upwards. There are magnets installed on the sides which will push the train forward. Like poles will repel and push the train forward, while the opposite poles attract and pull the train forward. Here is my project and experiments with the maglev train. Here you can see that the train is levitating. It is not leaning as there is support on the side, and it is not falling or leaning because the wooden train weight is balanced. Steps to make maglev train. To make this train, I used a wooden block and shaped it like a train. I placed magnetic strips on the track that I measured and left 2 millimeter space on each side. It was very important to make sure the North Pole is facing upward. Next, I glued magnetic strips underneath my wooden train and made sure the North Pole of the magnetic is facing outside. To support the train from the sides, I used 90 degrees plastic angle strips. Make sure they are not made out of metal or your train will stick to it. It is important to make sure the train weight is balanced. Otherwise, it will lean over one side. If it is too heavy, it will not float. If it is too light, it will not stay on top. And if it is not balanced, it will lean over one side. Once the train was successful in floating, I added buildings and turned my project into a little city. Here is my project. In conclusion, the train was able to flow without leaning or falling, as there was balanced weight on train. The magnets were the same pole, so it helped the train float while the 90 degrees plastic angles supported the train. Jazakallah.
Jazakallah, Faris. It is an excellent project. I think this is the future for transportation, mashallah. Our first prize winner is Fateh Zirman Hadi. His project is electric motors, electricity, and magnetism. So let's see how he has built all this in one.
Bismillahirrahmanirrahim. Assalamu alaikum warahmatullahi wabarakatuh. My science fair project is about electric motors, electricity, and magnetism. I chose this project because I wanted to know how electric motors worked. This is important because a lot of companies have started to make electric cars, and if we can make more efficient and powerful motors, there will be no need to make heavily polluting gas cars. First, I did some research on how direct current motors worked. I found they use an electric current passing through a coil of wire to create an electromagnet, which is attracted and repelled by a permanent magnet. The electromagnets are turned on and off continuously to maintain the rotation as shown on the animation on the right. If we can make the electromagnets very strong, this will increase the repulsive and attractive forces between the magnets, making a more powerful and faster motor. Based on my research, I found that the strength of the magnetic field B in the coil is dependent on the current I, the number of loops N, and the radius of the coil R, according to the formula shown in Figure 1. Therefore, we can increase the strength of the magnetic field by increasing the number of loops in the coil. Because of this, I predict that the coil with more loops will spin faster than the coil with less loops. The materials needed to create my experimental setup are listed here. You can pause the presentation if you would like to review them in detail. First, cut 2 pieces of the 14-gauge copper wire about 28 centimeters long. Use pliers to bend the copper wire as shown in the image at the top left. Next, attach your 2 copper wires to the D battery using some zip ties. Then, connect some alligator clips to the wire and connect it up to a multimeter. Then, use your enamel wire and wrap it around a D battery. Count the number of loops, and when you're finished, you should have a coil that looks like this. Next, sand one end of the enamel wire until you can see the bare wire. This is because when the bare wire touches the 2 copper wires, it will conduct electricity through the coil, which will generate an electric field. When the coil turns, then the enamel coating on the wire will act as an insulator and the electric field will disappear. As the coil spins, the magnetic field turns on and off. When the magnetic field is on, it is repelled by the permanent magnet, causing it to spin. Measure the distance between the coil and the magnet. Keep it the same for all your tests. Then put some reflective tape on it so that you can record it in slow motion. You will also need to record a stopwatch in slow motion. This way you will know how much recording time 10 seconds is in real time. This will allow you to calculate the revolutions per minute. I created many loops with different diameters and different number of loops. Since cell phones have a compass, I figured they would have a way of measuring the magnetic field to find north. I searched for an app that could use the sensors on the phone to measure the magnetic field strength. During the experiment, I observed many interesting things. I noticed that the voltage dropped every time the motor turned. With a higher number of loops, I could feel a stronger magnetic field when I held the permanent magnet next to it. This table shows the data I collected during the different trials. I repeated each test a couple of times and took the average results. At very high revolutions, it became very difficult to count the number of loops, even in slow motion. So I used another camera to record the slow motion video, slowing it down even further, and counted the revolutions over 10 seconds. I always counted the revolutions from the last 10 seconds of the video. This way, I was always collecting the measurements when the motor was at full speed. I plotted a graph of the RPM and the magnetic field strength against the number of coils. The graph is shown on the right. The results showed that as the number of coils increased, the magnetic field strength also increased. However, the RPM decreased. This was a very puzzling result, contrary to my hypothesis. Next, I plotted a few graphs to analyze the effect of coil diameter on the RPM and the magnetic field strength. I noticed that with smaller diameters and the same number of loops, the motor spun faster and the magnetic field strength also increased. I believe this is due to the lighter weight of the smaller diameter coils and the stronger magnetic field strengths with the smaller diameters. Based on the results, my hypothesis was proven incorrect. The motor with less coils spun faster than the motor with more coils. However, the magnetic field strength was stronger for the coils with more loops. I believe the motor spun slower because the weight increase of adding more coils was greater than the force created of the magnetic field strength, as shown with the smaller diameters. Based on this information, I would need to use a very thin wire with many loops. This way, the increase of the magnetic field strength created by adding one loop would be stronger than the weight increase by adding a loop. Through the project, I also tried a few other things, like creating a commutator and using AC current to alternate the magnetic field of the coils, the details of which are shown in this slide. Jazakallah, and thank you for listening to my presentation.
Jazakumullah, Fateh. It was a very interesting project. Unfortunately, last part of the video, there was some technical issue. We were not able to watch, but inshallah, we will have it on our website, and those who are interested, they can watch it over there. In addition to these three winners, we have three consolation prizes. First is Nabil Nasser Sheikh Saib. He has made a project. It is titled, "Does the voltage of a battery affect the copper plating?" The second consolation prize goes to Saim Zishan. His project was Quiet Water Alarm. So he has made something very quietly working, I believe. And the third is Abshar Ahmed. He has made a laser security system. Back to Nabil Sahib.
Thank you, Dr. Saab. For this session, we have, I will introduce a few guests who can bring greetings and some encouragement to the young students. We have a distinguished professor of chemistry from the University of Alberta, Professor Dr. Eric Rivard, who was born in Newfoundland and received his doctorate degree from the University of Toronto. After postdoctoral research in the United States and Australia, he joined the Department of Chemistry at the University of Alberta, where he is currently a professor. He has given over 150 lectures worldwide and has received international academic fellowships from Germany and Japan. His research interests involve non-carbon, which is inorganic chemistry, with a focus of polymers and plastic, and light-emitting materials. So I invite Professor to say a few words for our students here.
So thank you very much, Nabil. Absolute pleasure to be here. And I saw the last 6 or 7 presentations from the young women and men. Absolutely brilliant. Well done, all of you. I'm very motivated. I want to go back in the lab and do more experiments now because of these excellent work I see. So thank you very much for enriching my day. And so I also want to let you know, all of you participants, that you're learning some very important lessons. You're learning about being creative, being curious, being brave. And what I mean by being brave is, as you all saw, maybe you had trouble with your experiments, you had to troubleshoot, change parameters. Your hypotheses may not have been correct, but that's a good thing. It's good to not be correct. Actually, most of the time, scientists are not correct. 90% of the time, they are not correct. So learn to embrace this. And as mentioned by Dr. Zubari and also Dr. Al Garneau, that science is central to the world. You can change the world. And Canada is very blessed to have such brilliant scientists. And just a last quick story, why I became a scientist is I was at first interested in mathematics, but I had a chemistry course in grade 10. And the teacher was an art teacher. So she brought art into chemistry. And for me, it was so beautiful, and it got me attracted. So in the future, for yourself, keep your eyes open and follow your heart. Do what you love. Then you'll make a big difference in the world. Thank you very much.
Thank you, Professor, for your kind remarks. As I said earlier, he will be here for the QA session that's going to be at the end. If any of the students who are viewing this award ceremony, they want to submit a question, they can go online, abdussalamsciencefair.com, and then there is a button there to submit your questions for the QA panel. So Dr. Eric Rivard would be a part of that panel. At this point, I invite Muhammad Faiz, who is a member of the legislation from Saskatchewan. He is a member of the Ahmadiyya Muslim community. In fact, he's the first Muslim to be elected in the provincial legislature of Saskatchewan. He was a small business operator who was born and raised in Pakistan, and he has been a role model for all recent immigrants. And let's hear what he has to say. And I believe there were students from his province who submitted projects as well. Go ahead, Muhammad
Thank you very
Faiz.
much, Nabil, and Muhtaram Amir Jamaat Ahmadiyya Canada, Malik Khan Sahab, and Dr. Hamid Mirza Sahib, Nabil Sahib, and all those MPs and MLAs around the province, around the country, and all those audience. Assalamu alaikum wa rahmatullahi wa barakatuh. Peace and blessing of Allah be upon you. I would like to begin acknowledge that I'm joining you from Treaty 4 territory and homelands of Métis from Regina, Saskatchewan. Speaking to Premier Scott Moe, he told me to send all the congratulations to all the participants and the young scientists and all the winners. And on behalf of Government of Saskatchewan, I would like to say thank you very much for inviting us and taking a part in this special event. And it's truly an honor to be with you on the event, very special event. I would like to tell you that something, not the whole story, but what is the secret behind the success of Dr. Abdus Salam? It's about his parents. Chaudhry Muhammad Hussain. He was praying on the day of, he was very, very regular in prayer and in nawafals, and very regular in the church prayer especially. On June 3rd, 1925, it is a holiday of birthday of King of the United Kingdom. He was praying one time in his town, and he got a revelation that Allah the Almighty gave him a son. And when he asked, what is the name? And he was told his name is Abdus Salam. And later on, in January 29, 1926, a boy born in his house. And he wrote a letter to Hazrat Khalifatul Masih Sani Razillah Ta'ala Anhu and asking, can you please choose the name? And he also mentioned the roya about his boy. As Khalifatul Masih Sani Razillah Ta'ala Anhu wrote back, that's when the God, Allah Almighty, has chosen the name. Then please keep that. I'm not going to interrupt that. And you know, that's just one amazing story, amazing secret behind that boy. That's the prayer and the faith, the true faith in oneness of God, and the true faith and the true follower of Rasulullah and has a promised Messiah, and of course a true lover of Khalifatul Masih. And like Dr. Abdus Salam, his passion in the science, in the mathematics early in his life. And I'm not here to discuss all his accomplishment, but I would like to tell you that he believed that with the proper encouragement and peer support, any student can achieve the greatness. And so here we are celebrating his achievements alongside your own. I can tell you that any prominent university you cannot find in the world that he was not invited and was not honored to give a lecture into any big university from United States, from Europe, North America, in Canada, and everywhere. And you know, I was honored actually. I never met that personality, but I was at one time in my childhood was in Ivane Mahmood, where he was in there, and I only saw that personality. That was great actually. My father said that he is a doctor of the Islam. Well, I would like to say that events like this are the great opportunity to discover, explore, and have fun. And while we are gathered virtually here, to be sure to enjoy and being together while we are still on the distance. And I would like to give the congratulations to all the participants and to all those people got the prize of it. And on behalf of the government of Saskatchewan, a congratulations to everyone, and we are celebrating together. Thank you very much and have a wonderful day.
Thank you so much. Dr. Saab, we can proceed to the next section because I thought I saw Elisa Hepner from Hamilton Mountain join, but I guess she had to leave. So if she joins back, then we can get her in the next session. But at this point, we can proceed to the next section, which is girls grade 9 to 12.
Jazakallah, Nabil. Okay, we'll again start from the third prize winner. The third prize goes to Simran Malik Saiba. She has a project called Memories and Testimonies, the Neuroscience of Memory. It's a very interesting project. Let's see what she has done.
Bismillahirrahmanirrahim. Assalamu alaikum. My name is Simran Malik. I'm in grade 9 and go to Georges P. Vanier. My project is called Memories and Testimonies, the Neuroscience of Memory. Witness testimonies are one of the most common ways used to convict people of crimes. However, how useful can they be? Studies have shown from time to time that human memory is not like a recorder where you can just play back any memory clearly. The purpose of this study is to try to look at the accuracy of witness testimonies during a duration of time. To what extent does time affect the correctness of a witness account of an event? Witness testimonies are used all the time in both civil and criminal cases to convict or defend a person. The idea of witness accounts is to provide a first or second-hand account of what actually occurred in an event. There are many examples of cases where man has been convicted of a crime mostly because of witness testimonies. Though they are used all the time, how reliable can they actually be? Problems in testimonial evidence, especially eyewitness misidentification, have led to many wrongful convictions. One study concluded that about 0.5% of people arrested and charged are wrongfully convicted. Another article estimated that about 8,500 people are wrongfully convicted every year. Though this seems like a small number and it is just an estimate, eyewitness misidentification is one of the most causes of wrongful convictions. I hypothesize that the length of time increases, the amount of correct eyewitness of an event by an individual will decrease compared to when the individual first witnessed the event. I base my hypothesis on the background information I just presented. In order to understand how time could affect a witness testimony, one must realize that a testimony or account comes from memory. Therefore, these accounts are actually recollections of memory. Much of this research done for this topic was based on memory and forgetting. Due to time constraint, I cannot go through all my research. Some topic researched are listed here. I used the following materials listed here. The independent variables were the answers to the questions in the quiz given to the subjects after a period of time. The dependent variables are the correctness of the subject's answers and the variances between the subject's answers from the different period of time, and the controlled variables were as follows. The quiz given and taken at the same time, they all saw the same event, and the subject ages ranged from 14 to 15-year-olds. So the procedure I used to conduct this experiment was I orchestrated a skit. I had a kid visit a class in my school. Beforehand, I made sure the kid knew no one there in class. When the kid arrived, I had him first come in and had him introduce himself as alumni to my teacher and everyone in class. He then talked to the teacher for about 10 minutes about school and mathematics. I made sure he spoke out loudly and that he was talking to everyone. After the skit, I proceeded to provide the test to the 15 test subjects that had seen the event. I made sure no one cheated off another's quiz, and they were given only 15 minutes to answer the questions. The next time I gave the test was a day after the day of the skit. I gave it around the same time and I followed the same procedures. I repeated the same procedure with a week after the second test and then repeated the same procedure with a month after the third test. I then calculated and made a bar graph of the spread of how many people got the questions right for each test, as well as calculated the average percent change of how many people got the questions right from results of test 1 to test 4. I then analyzed the results. These were the questions given and the correct answers for them. I found out after running the experiment that in the first day of the test, pretty much 100% of the questions were answered correctly. One day after test 1, test 2 showed a minor decrease in number of correct answers. Test 3, given a week after test 2, showed a noticeable decrease in the number of correct answers. Only one question maintained a full number of correct answers. Test 4, given a month after test 3, showed not one question had 100% correct answers. And by comparing test 1 and test 4, one can see over time how the number of correct answers decreases. 46.06% is a very significant and important number, as it shows that almost half of what was learned was forgotten. In conclusion, the result of my experiment has supported my hypothesis. I was able to show that as time passed, the subjects' memories of the event were different from what they originally witnessed the event. The correctness of their memory decreased as time went on, decreasing in an average of 46.06%. Various things could have caused this, from memory falsification to just forgetting certain details of the event. One of the biggest things I could have done to improve my experiment was to make my event skit more meaningful. If my event was more meaningful, such as someone getting hurt, there would have been a bigger chance that the event would have stayed in the subject's memories. By seeing how time can alter one's memory or make them forget, we can see how these same effects apply to testimonies. If information can be forgotten or altered at such a rate, then why should we have people testify at trials months after a crime has been committed? My experiment has also made me curious about some other things. First, I would like to understand exactly why our memories get altered and if we can stop that. Also, I would like to look at its ways for us to retain our memory. This would be a major help in the criminal justice system as well as practical uses. The field of psychology is a continually growing field with new discoveries every year. There's still so much that we do not know or understand about it. In the future, I hope to continue my research in this field in order to improve our lives and look at other real-world applications. Jazakallah for your time. Assalamu alaikum.
MashaAllah, very good project. It is very interesting how we can look the memory, how it functions, how it fades. Very good, mashallah. The second prize winner in this category is Arusa Saleh. She has made a project where she will demonstrate can water float on water. So let's see how water can float on water.
Assalamu alaikum. My name is Arusa Saleh and I'm from Martindale, Calgary. My science experiment is whether water can float on water. Table of contents. Introduction, background info, experiment, layout of project, results, our findings, conclusion, what we learned. Introduction. Thermohaline circulation is deep ocean currents that are driven by differences in the water's density, which is controlled by temperature, thermal, and salinity, haline. In polar regions, the ocean gets very cold, forming sea ice. The surrounding seawater gets saltier as sea ice forms because salt is left behind. As salt concentration rises, density increases because the salt molecules can occupy spaces between the water molecules. Surface water is pulled in to replace the sinking water, which eventually becomes cold and salty enough to sink. This initiates the deep ocean currents driving the global conveyor belt. This is a diagram showing thermohaline circulation. The scale below shows salinity levels in different areas of the map. Experiment. The goal of this project is to investigate what happens to layers of water with different densities caused by temperature and salinity. The questions are, how does the temperature and salinity affect the density of water? The effect on our experiment. In nature, where are places that waters with different temperatures or salinities meet? If the temperature of water affects the density of water, then the layers will float on top of each other because warm water is less dense than cold water. If the salinity of water affects the density of water, then the layers will float on top of each other because salt molecules take up space and increase water density. Manipulated variable, salinity, temperature, responding variable, density, controlled variable, amount of water or freshwater density, the control, baseline to compare results to, freshwater. Materials. Table salt, you will need table salt and measuring teaspoon, food coloring, at least 2 different colors, hot and cold water, a hydrometer, a thermometer, 1 cup or glass, make sure it's wide enough to see the colors properly, a syringe or eyedropper. Procedure. Fill a large cup with room temperature water, ours was 20 Celsius. Measure the density using a hydrometer. Pour some of the cup water into a tinier cup. Add drops of food coloring. Take a syringe and fill it up with colored water. Put drops into the large glass. Continue adding until you are satisfied. Record your observations. The next part is for the salinity experiment. Repeat step 1 to 4. Add about half a teaspoon of salt. Measure the density using a hydrometer. Repeat steps 5 to 7. Procedure, hot and cold water. Fill a large cup with room temperature water. Measure the density using a hydrometer. Pour cold water into a tinier cup. Make sure the temperature is lower than the room temperature. Ours is at 10 degrees. Add a couple of drops of food coloring. Take a syringe and fill it up with cold water. Add a couple droplets of the cold water in the large glass. Observe what happens. Repeat steps 3 to 5 for warm water. Make sure the temperature of warm water is higher than the room temperature. Ours was 61 Celsius. Use a different color than the cold water. Also, before you start this, make sure that you measure the density of both the cold water and the warm water. Results. The first photo shows how we added the colored water into the full cup. The last photo is of the thermometer reading, which is at 20 Celsius. As you can tell, the water droplets that we are putting in are slowly moving towards the middle. As you can tell, the top photo on the left side shows the tinier cup and the bigger cup with the thermometer. The photo below shows the hydrometer, which is 1.033 for density and 43 for salinity. The middle photo shows how we added salt water into the full cup. In this experiment, we are putting colored salt water in fresh water. It is sinking to the bottom. The top left photo shows the thermometer reading in cold water at 10 degrees Celsius, the red, and hot water at 61 degrees Celsius, the green. The second photo on the right shows the hydrometer readings. The clear water is the cold water. The density is 1.016 for cold and 1.008 for warm. The third photo shows the cups and the syringes. All 3 photos show the gradual addition of the mixtures into the full cup. The first is cold water, the second and third is warm water. We took a break between the second and third to allow for the mixtures to mix. Here are 2 videos. As you can tell, within seconds, the cold water is going to the very bottom of the cup. Now, we are going to be putting the hot water. As you can tell, the hot water is floating on top of the cold water. This is because of the density. As you can tell, in the extra part of the experiment, the purpose was to test if the water levels would rise or stay the same if the ice was placed in it. In the fresh water, the liquid level stayed the same. The entire volume of solid ice that was above liquid level got compressed because of the density changes as the water turns back into a liquid. So here it shows the water levels. In the salt water, the liquid level rates considerably higher. Salt water has a higher mass than fresh water, so it's a little more dense. When the fresh water melts, it decreases the salinity of the ocean. Less salt equals less dense. It's because of this that the volume of the salt water expands when the fresh water sinks into it. So here it's showing the water level. And it's showing how it's rising. Conclusion. Findings. First experiment, fresh water. Density in the syringe is equal to the density of water, so it floated in the middle. The density is 1.006 at 20 Celsius, which will remain constant in all the experiments. Second experiment, salt water, using 1.006 at 20 Celsius. Density of salt water is 1.033 and the salinity is at 40. The high density of salt water led it to sink to the bottom. Third experiment, first part, cold water. Density of cold water is at 1.016 at 10 Celsius. Cold water's density was higher than fresh water, so it sunk. Third experiment, second part, hot water. Density of warm water is at 1.008 at 61 Celsius. The warm water did not rise on top of the fresh water. Rather, it sank and floated on top of the cold water. This is because it was more dense than fresh, but less dense than cold. In nature. The Dead Sea. The Dead Sea is the middle of the desert, surrounded by Israel, the Palestinian West Bank, and Jordan. It's called the Dead Sea because nothing can grow or live in the water. It is in the lowest valley on earth and landlocked. All the minerals and salts from the surrounding waters flow into it. It's 9.6 times saltier than the ocean, 34% salinity, mostly at the bottom of the lake. A person's body weight is lighter than the density of the salt water in the Dead Sea, leading to natural buoyancy. The further you weigh, the more you'll experience the feeling of being pushed up, which makes swimming here impossible. Melting glaciers. Density differences between saltwater and freshwater result in a difference between the volume of seawater and the freshwater. Ice melts faster in saltwater because saltwater has a lower freezing point than freshwater, so the ice will have to absorb less heat in order to melt in the saltwater than in the freshwater. Both thermal expansion as the water warms, the volume increases, and ice melting are the results of climate change. In conclusion, I have learned a lot from this experiment. I have learned the importance of buoyancy, the effects of climate change, and the effects of temperature and salinity on density. I also got to explore places where this phenomenon is happening constantly. Jazakallah for your time. I hope you enjoyed my project.
Yes, Sarusa, we really enjoyed your experiment. It was a very good experiment. Okay, our first prize winner is Nidaun Nasser. She has made a project which is titled, If Sports Drinks Actually Have More Electrolytes in Them, or is there a healthier option? Let's see.
My name is Nida, and the topic of my project is, Are sports drinks as healthy as you think? Sports drinks are one of the most popular ways people rehydrate themselves after a harsh workout. Not only do sports drinks rehydrate you, they also claim to replenish the electrolytes lost through sweating. Electrolytes are essential minerals that are vital for many key functions of the body. There are 4 main minerals that count as electrolytes: potassium, magnesium, calcium, and sodium. The purpose of this project is to understand whether sports drinks really give you more electrolytes as they advertised, or is there a healthier and better alternative. I will be looking at different sports drinks companies and comparing them to freshly squeezed orange juice, figuring out if orange juice has more electrolytes. I hypothesize that the fresh orange juice would have more electrolytes and be a healthier option. The main essential minerals that are in electrolytes are in oranges. This indicates that an orange would have more electrolytes than the sports drinks. Fresh orange juice also has no preservatives and sugar added to it, making oranges healthier to consume. So the materials you need for this project are a straw, a copper wire, a multimeter, 3 alligator clips, 3 9-volt batteries, a 9-volt battery clip, Powerade, Gatorade, distilled water, and tap water. For the measurement of the liquid, I'll be using the same amount, which is 1 cup, about 250 milliliters. So to begin with the experiment, I'm going to make the conductance sensor, which will help us find the electrolytes. For this, you will need a straw, scissors, and 2 copper wires. The conductance sensor is ready. As you can see, I have wrapped the copper wire around the straw. Now that we're done, we will continue on by making the conductance measuring circuit. So before I make the conductance measuring circuit, I want to explain how I made the alligator wires on my own. This is the alligator wire I made. So to make this, you need copper wire with 2 bare ends and alligator clips. So how I made it was I took one bare end of the wire and put it inside of the alligator clip. Until it was quite far in, I took a strip of tape and just attached it around the wire to keep it insecure. And there you have it, alligator clips. So to make the conductance measuring circuit, you need to take your multimeter and take the positive side of it and connect it to an alligator clip. Then you're going to take your battery and connect your battery clip to it, and take one side of one wire of your battery clip and connect it to the alligator clip. Now you're going to take another alligator clip, connect one side to the other wire of your battery clip, and one side to our sensor. And then you're going to take your last alligator clip, connect it to the other side, and close the circuit by attaching it to this wire. Now that I have explained the procedure, let's start the experiment. I will first be testing tap water. So before starting, just make sure to have your multimeter set at 200 M. I will place the sensor into the tap water and turn the multimeter on. Now I will be conducting the same process with Gatorade. Now before continuing on with the next liquid, I will just quickly rinse our sensor with distilled water. Now repeating the same process again with Powerade. Now last but not least, our orange juice. So now I will repeat the same process 2 more times. The variables and controls in this project is that I'm only using one type of battery. The battery was also full with 9 volts. I used the same volume of liquid for each drink. I lastly left the sensor in the liquid for the same amount of time for each drink. Before continuing to find the amount of electrolytes, I will change the unit of milliamps, which the calculations are in, to amps. To find the amount of electrolytes in the drinks, I first have to find the average of each trial. After finding the average to find the electrolytes, you have to divide the current of each drink by the voltage. This will equal to the conductance. Conductance is proportional to the number of electrolytes. The current will be the average current we calculated for each drink, and the voltage will consistently be 9 because the battery had 9 volts. In conclusion, orange juice does have more electrolytes than sports drinks. Gatorade and Powerade have a lot more sugar, preservatives, food coloring, and calories in them. Fresh orange juice does not have all of this, making orange juice a healthier and much better option to consume.
Jazakallah, Nida. It was an interesting project to prove by yourself that we should have healthy choices. Very good. Okay, in addition to these 3 winners, we have 2 constellation prizes. First is Atiya Chaudhary Saiba. She has made a project called The Mysterious Respiratory Illness, a Case Study. And the second is Kashmala Zishan Saiba. She has the project called Function of Eyes, How Do We See? This concludes the girls 9 to 12 category prize winners. Back to Nabil Sab.
Thank you, Dr. Sab. So just as a reminder, all the projects that were submitted, including the ones that are receiving the consolation prizes. So we're not showing their projects in this award ceremony, but they are all available at the abdussalamsciencefair.com website or the Abdus Salam Science Fair YouTube channel. So students are welcome to view these projects. And then the second reminder, if students want to submit a question for the QA session, they can go to the website and submit a question. There's a button for questions there. At this time, I will invite Member of Parliament, Ikra Khalid from Mississauga, Erin Mills, to join and say a few words. She is a lawyer and a public servant, immigrant, and a longtime resident of Mississauga, and has been here to serve the diverse needs of the residents of Mississauga. She works to inspire others to take an active role in building Canada. She was born in Pakistan and moved to Canada with her family at a very young age. She studied criminology at York University and moved on to complete her law degree at University of Michigan. Completing her law degree at the University of Michigan, Ikra returned to Mississauga, where she went on to work for the city's legal department and continued to serve. Ikra was actively engaged in the issues facing Canada and people around the world. Ikra has served as a member of parliament since 2015. So I invite her to say a few words for these young scientists.
Thank you so very much. And I think I see that my colleague Yara Sachs is here as well, member of parliament from York Centre, I believe. Listen, I remember the last time that I attended this event, and I can't believe that it's been a year has passed. It's been a challenging year, and I think one of the most uplifting things that I've been able to do over the past number of weeks is to listen to these projects from these young girls. And it really reminds me of how much more we need to do collectively as a community, as a society, to ensure that we are investing effectively within our science, technology, engineering, mathematics, arts, industries, and education fields, and the importance of having women be part of that conversation. So I really applaud all of you in encouraging these young women in their science projects and ensuring that they feel comfortable and that they feel included in having a future in the STEM fields. Our government has invested significant dollars, for young girls that are wanting to pursue careers in the STEM fields. And I am here as an ally, as a friend to the community and to these young girls to ensure that we are making significant progress for not just Canada, but ultimately all of the world. We know that the past number of weeks have been very, very difficult for the democratic world. And watching invasions happen and watching what we've spent decades building as democracies kind of crumble and be questioned. I think our youth play a very, very important role in how we rebuild ourselves as communities, as societies, and as a world, and ensuring that a rule-based order sustains and ensures that the kids of today and the leaders of tomorrow have a secure future in which they can thrive and in which they can use their brains and their intellect to ensure that we're progressing, that we're continuing to push that needle further towards progress, inshallah. I am here as an ally and as a supporter. I will include my contact information for anybody who wants to reach out to me to, for mentorship, for opportunities here in Mississauga. And I wish all of the students the very, very best. I know that there's a lot ahead of them, and I know that they are going to do our country proud. They're going to continue to build bridges, and they're going to continue to push that needle further towards progress. Jazakumullah khair to all of the organizers, to each and every one of you that continue to nurture, that continue to grow and water these seeds that are going to grow into very, very big trees for our country, inshallah, one day. And know that I'm always here to help support that process and that progress. Jazakallah khair, and I'll leave it there.
Thank you so much, Ikra. I just wanted to remind the viewers that Ikra is a very strong advocate of women issues and steadfast ally in the cause of human rights, speaking on issues as human trafficking and the Rohingya genocide and things like that. So, and especially the women who want to, who participated in today's science fair should reach out to her and get more advice on getting into these kind of things. So thank you once again very much. And now I invite His Worship, Mayor David West of Richmond Hill. Mayor David West has served the residents of Richmond Hill for years as a local business owner and has demonstrated leadership through various volunteer community positions. With the Richmond Hill Chamber of Commerce, he has been the chair of the Government Affairs Committee, a member of the Board of Directors, and has also served as a chair of the Chamber. A committed contributor to his community, David has volunteered with Yellow Brick House, McKinsey Health, and the Toronto Waldorf School. David has served on numerous Richmond Hill committees and task forces, including the Yonge Street Subway Task Force, the Cultural Leadership Council, the Committee of Adjustment, and Community Hub Liaison Committee, etc. I invite the mayor to say a few words to these young emerging scientists.
Well, thank you very much. It's a real honor and pleasure to be here. I've been tuned in for the last hour, and wow, the presentations so far have just been simply remarkable. So thank you very much to the organizers of this science fair. I think this is just a great event. And congratulations to not just the winners, but also to those that have participated. So I'm honored to bring greetings on behalf of the Richmond Hill City Council and our community. I know this is a countrywide event, and for those of you that don't know, Richmond Hill is located just a little bit north of Toronto. I'd like to think that Toronto is a suburb of Richmond Hill. But anyway, I just, when I was invited to this, I was very excited to be here. I remember very distinctly when I was in grade 6, 7, and 8, participating in a science fair very similar to this. And, it was a great event, and I remember it very clearly. But I think what I remember as a person that's much older than that now, many decades later, is all of the things that stuck with me about the whole process of learning in science and being able to take a problem, really delve into it, and then be able to present your ideas and findings to other people. And that's what we're seeing here today from our students. I went on later in my career to be a teacher, and I taught science, and I know how important that is. And I also know how young minds and older minds like us really take the wonder of the world, and science really helps us to explain that. And, the world makes a lot more sense most of the time when we have a better understanding of science. And I think that that's really something that we're seeing here today. We are lifelong learners our whole life. I know I certainly am, and I think that makes every day an exciting one. And these young people here today are showing us older folks just how much learning can be done. And this is a fantastic thing. So I thank you to the organizers of this event for facilitating this great process. And again, to those of you that have participated in this event, congratulations and well done. To those of you that won, an additional congratulations and well done. And I look very much forward to seeing some of your names as future leaders in this field, in the future. So thank you very much again, and have a wonderful rest of the day, everybody. Thank you.
Thank you, Mayor, for your kind remarks. I turn it back to Dr. Hamid Mirza Sahib to introduce the winners of the final segment, which is boys grade 9 to 12.
three top winners, which will be watching their videos. The third prize winner is Nuruddin Chaudhry. His project was Hearing Voices from the Past. So let's watch how we can hear those voices of our beloved ones.
What if we were able to hear the voices of historic figures, tribesmen, leaders, kings, even prophets? What if we could hear their actual voices, regardless of if they are deceased today? This is a possibility through the means of advancement in radiology. In relation to this concept, the Quran has mentioned, "And everything have we recorded in a book." In Tafsir Kabir, this exact concept was postulated. Hazrat Muslim Maud Anhu states, "I wonder sometimes that it is not so far-fetched if science continues to progress to a degree where we can record the voices of the previous times. If such a machine is invented, it may well be possible that we are able to listen to those ahadiths which are currently written in books directly from the mouth of the Holy Prophet sallallahu alaihi wasallam." The idea of reviving voices from the past isn't as far-fetched as one might think. For instance, trees are known and studied for their rings. These tree rings capture climate over 30 years or more of a given region, and trees live for hundreds of thousands of years. As a result, these rings inside the trees can give a glimpse of the surrounding climate over its lifetime. Similarly, glaciers are also reminiscent of the past, as the air bubbles within it can determine how much carbon used to be in the atmosphere long ago. They can also be used to analyze ice crystals to determine how much water was on ice versus liquid in the past. These basic principles visible in the nature of things are just some minimal ways we can perceive how even nature keeps a record. Overlooking this concept isn't something that has not been invented in the past. With the invention of the phonograph and phones, these devices allow us to record our voices in the present and listen back to them in the future. But in this experiment, reviving voices from a non-present device is the exact objective. Let's begin with a basic law. The law of conservation of energy states that energy can neither be created nor destroyed. It can only convert from one form to another. And sound is energy, thus meaning that sound waves cannot be destroyed. This supports the fact that sounds can be revived, as this law creates the means for sound to be reproduced. Sound is produced through vibrations of nearby molecules, which creates a pressure wave. The pressure wave causes the surrounding air to also vibrate. Eventually, these molecules carry the vibrations over for others to hear. But sound waves don't last due to friction. Most sounds last 10 seconds and become unmeasurable after 60 seconds, but as this law states, energy cannot be destroyed. Sound waves are like this graph. After a while, they die down and diminish below audible levels. The amplitude dies down to almost zero, which explains why sound waves become unmeasurable after a period, but this does not mean that there can't be a means to reproduce these sounds. In the current century, we have been able to capture sound waves through the lens of a camera, a whole other concept that was inconceivable decades prior. Seeing sound with our eyes through the use of a centuries-old technique, this allowed science to achieve something incapable before. Similarly, in 2003, a professor was able to discover what the Big Bang sounded like, the very first sound in our universe, through the use of data from a probe that measures temperature differences across the sky in the cosmic microwave background. This data was then converted into a sound file. This is a big step in audible sound evolution, as this creates a means for past sounds to also be recreated. Although no satellite data has recorded data on voices of humans from history, there have been less traditional and unordinary ways of reproducing voices. This experiment is done through the use of a corpse. In this example, it is the form of a 3,000-year-old mummified individual whose voice was accurately reproduced through accurately and sophisticatedly measuring his extant vocal tract and reproducing it with a 3D printer that printed a vocal tract organ with a controllable artificial larynx sound. The precise measurement was taken through computer tomography scanning, and the accuracy mattered because every individual's vocal tract produces a sound unique only to them. Although the process is still not as refined in many aspects, it's still a massive step in evolution. Variables and controls that can alter this experiment are factors such as the corpse's perfect preservation of soft tissues. Otherwise, with only the skeleton, the process becomes impossible. But even in the case of soft tissues being preserved, such as for this 3,000-year-old priest, the process of synthesizing can still be distorted and incomplete. On top of this, the actual speech patterns are also needed for the intention of reproducing the individual's voice, which is not similar to modern speech patterns, and thus is another uncontrollable variable. Although digging up corpses is strictly contradictory to the teachings of Islam, this method is plausible for now. Though through the advancement of technology, a more accessible measure and conventional method may come to pass. The method of reproducing a millennia-old conversation is just a theory, but as this experiment goes to show, simply reproducing voices of historical figures is experimentally possible. But through the advancement of technology, a better method for reproducing voices may emerge, which may open doors to bring the theoretical possibility of actual historical conversations back.
Excellent work. It is very interesting area of research, mashallah. Our second prize winner is Danish Mahmood. He will be showing pH scales.
Assalamu alaikum, my name is Danish Mahmood and I am a grade 12 student at St. Roch Secondary School. I am currently in Spring Valley in Brampton and today I'm going to be talking about pH skills. The table of contents. Today we're going to be going over the introduction, hypothesis, procedure, results, as well as the conclusion. Here's a quote by the developer of the pH scale himself. Introduction. People use things in their own home that are acidic and bases every day. An acid is a chemical substance that neutralizes alkali, a molecule or entity that can donate a proton. On the other hand, a base is a material that can take hydrogen ions and protons. When dissolved in water, it becomes an alkali. Acids are usually 1 to 6 on the pH scale, while bases are usually 8 to 12 on the pH scale. Neutral is usually 7, which is right in the middle. pH is a figure expressing the acidity or alkalinity of a solution on a logarithmic scale. pH is equal to negative log C. C is a hydrogen ion concentration. pH levels are very important, especially in our body and in nature. Our human blood is 7.35 to 7.45 on the pH scale, and if our pH levels were to change, it would be extremely hard to survive. In nature, if the pH was to drop, then we could see things such as acidic rain happen. It would also affect plants, animals, and many other things. Here's my hypotheses for all of the substances and solutions that we are going to be testing today. The procedure of this experiment. The first step is to cut red cabbage and place it into a food processor with a little bit of water. Secondly, we're going to filter it through using a coffee filter into a pot and boil it for roughly 7 minutes. After boiling it, we're going to filter it again into a bowl and let it cool down for 10 minutes. We're going to place a new coffee filter into the cabbage juice for another 10 minutes. Then we're going to take it out and let it dry. The next step is to cut the cabbage into test strips to use on your own household items, as you can see in the pictures to the left and right. Put each item into separate cups and dip one test strip into each substance. Observe the reaction and document the results. Depending on the change of color, you'll be able to tell if a substance is acidic or basis. Here are the results of all of the things that I tested. So for example, we can see that ginger ale came up to 2.94, which is acidic on the pH scale. Tabasco sauce came in at 2, lemonade came in at 2.6, sparkling water at 5.5, tap water at 7.2, dishwasher detergent came in at 8.2, baking soda at 8.3, carpet remover at 10, bleach at 13, Windex at 10, Tide at 8.6, mouthwash at 4.5, and lastly, apple juice at 4. The conclusion is that my results showed that many of the household items are in fact acidic as well as bases. The results provided proved to be consistent with my hypothesis and that acids and bases can be distinguished from our senses. In a way, humans are natural indicators because using our senses we can determine what is more acidic or basis. Determining the pH level of a solution is extremely important because the pH level determines if it is safe or not for a human body. If something is too acidic, it can damage a body or harm the skin. Thank you very much for listening today.
Thank you very much, Danish. I'm sorry there was some technical issue. I think it is reoccurring and we were not able to watch all of the video. However, these videos are available at the Abdus Salam Science Fair for all those who wish to watch later on. So they can watch all these videos. Our first prize winner in this category is Osaf Mirza. He has made a project called Bicycle Generator. So let's see how he has made this generator and how it functions.
फूल तुम पर फरिश्ते निछावर करे और कुशादा तरक्की की राह करे.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Asaf Mirza.
And my name is Rayan Mirza.
And we are from the Mississauga West region. For our Abdus Salam Science Fair project this year, we decided to create a bicycle generator. Starting off with our hypothesis. If enough chemical energy is converted into electrical energy, then it can power a light bulb or other appliances.
The law of conservation of energy says that energy can neither be created nor destroyed, and the total energy in a system is conserved. Since the energy is conserved, the electrical chemical energy in the person's body is converted into mechanical energy in the bicycle, then electrical energy in the motor.
This is our model for our original project. So the parts we used for our project were 2x4 wood, a V-belt, a diode, a battery, an inverter, wires and alligator clips, and a 12-volt motor.
So how did we build a bicycle generator? For the first step, we found a working bicycle and removed the back tire. We then used the bike to generate mechanical energy.
For our next step, we built a stand to elevate the bike.
And then we elevated the motor.
Next, we attached a V-belt to the rear tire. We used a V-belt to create a link between the motor and the wheel.
Ampere's law states that an electric charge passing through a loop circuit produces a magnetic field. The interaction of the internal electromagnet with a surrounding fixed magnet produces a force that causes the movement of the armature.
So how is the current produced? The spinning tire causes the motor shaft to rotate, which produces a current through the leads. This was in accordance with the Faraday's law, which states that whenever an electrically conducting object or material passes through a magnetic field, an electric current will begin to flow through it.
There are two types of current. There is direct current, DC, and alternating current, AC. For example, a car battery provides DC for all the electric components. Our homes are powered by AC.
We learned that we can't connect our lamp directly to the motor unless we use an inverter. So the current that was produced was DC and the inverter changed it to AC.
The electrical energy produced was enough to light up the lamp.
And finally, for our final step, we attached our light bulb to the inverter, and that was our working project.
When working on the project, we faced a couple of problems. We learned that the bulb would turn off if we did not pedal constantly, or when we stopped pedaling. We thought if there was a way to store the energy that was produced which can later be used to light up the bulb constantly. The bike stand was also difficult to make, as it was not able to support the weight of the rider. We decided to flip the bike, and instead of riding, we decided to use our hands to pedal.
So how can we expand on this project? We conducted a research to see how the energy can be stored, and we saw that using a battery will do so. We then got a battery, but that still wasn't enough. We wanted to have the current flow only in one direction, so we used a diode.
We used a diode where we connected it between the motor and the battery. The anode was pointed towards the motor, and the cathode was pointed towards the positive terminal of the battery. The battery also acts as a middleman, where we store the energy that can be utilized later, like how a solar panel operates.
Then we placed the diode in a series with the motor and the battery.
For the data collection, we found out that using a voltmeter, we found out that the voltage was 12 volts and the amps was 3.3 amps.
For our results, we found that in part 1, if the voltage wasn't consistent, then the bulb will not light up consistently. We ensured that the voltage was constant and stable. When we stopped pedaling, the bulb would stop and the energy wasn't stored. For our part 2 project, we incorporated a battery and a diode which stored the charge in one direction and kept the bulb consistent. There also needed to be a huge tension in the V-belt for consistency in lighting the bulb.
In conclusion, our hypothesis was correct.
Jazakallah.
MashaAllah, Asaf Mirza and your brother, both of you have generated you have demonstrated bicycle generator. Stay tuned. I think today we have our guest, our keynote speaker. He will be interested in furthering your ideas and guiding you. With this, we have 2 more constellation prizes in this category. So first prize goes to Nabil Ahmed. He has project entitled Effects of Evolution. And the second constellation prize goes to Wajahat Chaudhry. His project was on black holes. With this, we conclude the announcement of the awards. Back to Nabil sir.
Thank you. Yes, that was the last session of the last category. At this point, we have a few more guests who are going to bring remarks. First, I'll invite Yara Sachs, Member of Parliament for York Centre. Yara brings a Canadian and global perspective to the work it takes to create a community engagement and achieve real progress. She believes deeply in the values of equality and diversity and has devoted her career to addressing societal inequalities. She has experience in advisory roles for policy, communications, and project management. Having worked in the office of the Mayor of Jerusalem and in advancing people-to-people programs as part of the Israeli-Palestinian peace process. I invite Yara Sachs to bring greetings to the Abdus Salam Science Fair for the young students here.
Thank you so much for that warm welcome and introduction. Assalamu alaikum to all the student scientists and to our esteemed guests that are joining us here today. This is actually my second year joining the Abdus Salam Science Fair, and it's such a special part of my weekend when I'm able to sit and listen to the many students, both boys and girls, who have presented such incredible thought-provoking projects for us to think about the world we live in and try to understand it and improve it for all of us. You know, the process of discovery in science happens thanks to collaboration and cooperation. And the inspiration for it comes on the footsteps of those who discovered before us. And each year that students present, they are learning from others before them to be able to expand and explore and go deeper into their own studies and experiments. when Muhammad Abdus Salam himself won the Nobel Prize in Physics in 1979, he shared it with Sheldon Glashow and Stephen Weinberg for his contributions to electroweak unification theory, meaning we do this together. We do it coming from backgrounds and faiths and religions from all over the world in the pursuit of science and knowledge and understanding to make our world make sense. And particularly, as my colleague MP Ikra Khalid said, this is a time where more than ever, we desperately want our world to make sense during these challenging moments that we've gone through and are currently witnessing. So working together, our collective faiths bolster us in the discoveries that we make to do good for one another in the communities that we come from. And this is a powerful statement because it's the power we share as young scientists and young people in the communities we're in from across Canada, where science and innovation, whether it's boys or our girls, strengthen the diversity that we share in the communities that we live in, and celebrating our knowledge together from a place of inclusivity and from a place of cooperation. And I think that's really important right now. It certainly is in the work that I do, as Parliamentary Secretary to Families, Children, and Social Innovation, where I say often, diversity is a fact in the country we live in, but inclusivity is a choice. And programs like the Science Fair show us that what happens when we work together and share our knowledge. To each of the students that I've witnessed your projects today, I've seen your love of science touches on every aspect of our lives, and from the power of function and memory, and the power of the voices from our past and how they inspire us today, to exploring the physics and functions of one of our most essential needs, which is water, and how we manage it and understand it in the world we live in. You've asked hard questions and sought important answers. Our young peoples are the creators and innovators and builders of our future. And in days like today, I see how much they're engaged in it right now. And we should all be so inspired by the work that they do. Muhammad Abdus Salam famously said that scientific thought and its creation is the common and shared heritage of humankind. And it really is true then and now today. So to all the students, I'd like to say, may you continue to explore, continue to create, continue to succeed together. Atazakum al khair and mabruk to all of you, to the participants and to the winners. And I'm thrilled to be joining you. Thank you again. Shukran.
Thank you so much. At this time, we have, I think, one more guest who will bring greetings on behalf of the York Regional District School Board, Mia Nadeem Mahmood, who is a trustee of the York Region District School Board. He is a member of the Ahmadiyya Muslim community and has held many offices in the Ahmadiyya Muslim community as well. And he is an IT professional by profession, and currently he is serving as a trustee. He takes keen interest in youth and student issues and is passionate about getting students to excel in science and technology. Nadeem, please go ahead.
Thank you very much, Nabil. Assalamu alaikum. It's my honor and pleasure to welcome you all to the Abdus Salam Science Fair award ceremony and to offer my congratulations to all the students who have participated today. Students, your hard work and dedication are evident in the impressive projects we have seen shared throughout the science fair here. It is because of the scientists like you who ask questions about the world around us, explore possibilities, and seek new knowledge that we continue to gain new understandings of the world around us and enjoy so many advancements today. Advancements that support our health, the health of the natural world, and improve our quality of life every day. I sincerely hope that you will continue to stay curious and committed to lifelong learning and pursuit of knowledge. We know that few of us achieve success of our own, and I hope you all remember to thank the educators, family members, and friends who have challenged, motivated, and supported you in your journey. And I hope that they inspire you to lift up those around you as well. Indeed, you are already role models for your peers, shining a light on what can be achieved when you work hard and persevere. You have certainly inspired me I want to thank you, the organizers of Abdus Salam Science Fair, for providing this wonderful opportunity for youth to showcase their critical thinking, innovation, and scientific knowledge, and for creating such a fitting tribute to the first Muslim Nobel laureate, one that inspired the next generation of Muslim youth and young scientists. I wish you all the very best, and students, I hope you enjoy this moment. You have earned it. Thank you very much.
Thank you, Nadeem. At this point, before the QA session, and I just want to tell everybody that the astronaut Mark is returning for the QA session, as well as the professor from Alberta. I will ask Dr. Hamid Mirza Saab to introduce the keynote speaker at this point, and after the keynote speaker, we will have the QA session.
Jazakallah, Nabil. It is a great honor for me to introduce our keynote speaker. He is the founder and chief executive officer of ONE. He is a battery system engineer with over 30 years of experience in the development of electric vehicles and battery system technologies. His career work has focused on furthering the adoption of electric vehicles through advancements in battery safety, range, and cost. Mr. Mujib Ijaz Saab led teams at Ford Motor Company, where he developed Ford's Edge with HY series drive and Ford Fusion Hydrogen 999 that set a land speed record at Bonneville in 2007. He also worked for the Chrysler's important electric vehicle project. He was president of A123's Venture Technologies unit, where he had his team led the development of lithium-ion battery solutions for electric vehicles. And more recently, a senior director at Apple, where he developed noble energy storage solutions. Mujib Ijaz Saab holds 31 US patents in the field of battery technology and energy management systems. He is a graduate of Virginia Technology in Engineering. He also served in the past as Sadr Jamaat, Silicon Valley. Welcome, Mujib Ijaz Saab. It's a great honor for me to invite you today.
Jazakumullah for that kind introduction, and assalamu alaikum wa rahmatullahi wa barakatuhu to all of the participants on this very important Dr. Abdus Salam Scientific Award ceremony. As I listened for the past several hours to many of the youth presenting, I could imagine the kind of evolution of Dr. Abdus Salam's work from being his own work to now inspiring the work of so many youth around the world that are accelerating technologies and accelerating their scientific pursuits because of being inspired by him. It's interesting, I had the experience that he visited our home in Virginia when I was 10 years old. So not unlike some of the presenters, I had the opportunity to meet him. My father was a nuclear physicist working at Virginia Tech, and they would collaborate. My mother also was a solar scientist working at Virginia Tech as a professor. And really the conversation around sustainability and electrification was a persistent conversation around my dinner table. And you might say that you look for those things that inspire you, and you don't realize that when you're in the midst of a conversation about how electrons can be generated 10 different ways, but fossil fuels are only generated in time by one way, which is the earth takes billions of years to turn the materials into fossil fuel storage, but it's a finite resource. And my mother and father would both talk about how the future of energy was most likely going to transition away from fossil fuels and into sources that would harness electricity and electrons. And that's part of why I pursued the development of battery technologies and the pursuit of electric vehicles, is I bought into the idea that over time, the renewable energies, wind, solar, hydro, geothermal, and even nuclear power, as Allah would gift people with a deeper understanding of how to motivate a different source of electricity, that we would find over time that it would continue to climb, and Allah would continue to unlock ways in which we could harness more sustainable and renewable technologies. So I started pursuing my career in electric vehicle by joining a college project. And that's one sort of foundational point I wanted to make in my remarks here to you, is seek out those inspiring hands-on projects as you're going through your academic, whether you're in 8th grade or 12th grade or you're senior in college, as you seek out an application where it involves you building something. I so enjoyed watching the electric motor demonstration with magnetic field and the levitating train, and seeing the hands-on, because when you are hands-on, it creates curiosity, whether it's in chemistry, biology, fields of engineering, science, all of these fields. When you start applying the science and then you get curious and then you ask the question, how does something work? It motivates you to take it to the next level. And I myself, in my career with my solar car project in Virginia Tech, found that I was involved in trying to figure out control systems and batteries and motors and electronics and powertrains, and then how to marry those to vehicle technologies that are going to propel the future of mobility. And I went into 3 careers. I went through Ford Motor Company, then into A123 Systems, then to Apple. And when I was working through this, I actually became quite inspired by something that I read in a book about one of the founders of Apple, where it talked about when you seek to disrupt an industry, you have to imagine what that disruption needs to be that will transform the society into a place that you seek to create. And as an example, as I looked at electric vehicles, I could see the adoption of electric vehicles being a profound movement that would encourage the use of solar, wind, nuclear, that electrification would actually take root through the adoption of electric vehicles and mobility as one of the primary sources of consumption of electricity or of energy in general. And I looked at the ability to get the market started with a much higher aspirational goal than what most companies were going after. And I simply wrote down the goal that we could double the range of electric cars. It would transform the industry permanently, that we would then solve the adoption of electric cars, which would then promote the adoption of renewable energy, which would then promote the dwindle down the consumption of fossil fuel energies. And so as we started going after doubling the range of an electric car to increase the market share for all vehicles, making the electric car your only car, I then started looking at the raw materials. And actually in the raw materials study, the topic of human rights and where mining was going on and how mining practices were being employed, and even the conflict materials. You think of the topic where diamonds have been labeled as blood diamonds because of the practices. Well, cobalt was also a very unfortunate material that also had similar bad mining practices. And as I looked at other aspects of nickel and cobalt used in batteries today, I thought, let's make a human rights move as well as a safety move, which is let's eliminate nickel and cobalt, but still we want to double the range of electric cars. So we used new material ideas. And then as we looked at the next layer, it is to create the livelihoods and the wealth and the job creation, not just in one country that has all the minerals, but let's spread this technology evolution to where any country in the world could get access to the materials, because we selected sustainable materials that could be mined and locally sourced in South America, North America, Asia, Europe, Sub-Saharan Africa, Indonesia, any of these countries that are trying to grow their access to the renewable energy. So then as I wrote these goals down, we started thinking about what to name the company. I came up with, through prayer, the idea that I should name the company in a way that can glorify God. And what better way to glorify God than to name the company One? And One then needed a little bit more of an, I guess, an explanation to the people that would eventually come in to help me build the company. And E was very easy. It was for energy. And then I started thinking, after I committed in my mind that E would be for energy, what are the two other letters going to stand for? And then N quickly came to me that the word next is a good idea, because we're trying to move from fossil fuels into electrification. And the final word is the most substantial way that I can describe my idea of this company, is that we're really on a journey to find our next energy. And it's the global 7 billion that really do need to enter the world of electrification, because actually energy is education, democratizing energy and democratizing electricity and giving people sustainable access to renewable energy to store the energy is a profound movement that is starting to happen. But in order to realize that access to this energy, which is through solar and wind, as two examples, and hydroelectricity, those energy sources are time-based and not permanently available. And in that we have the ability to access these energy sources with renewable energies, we need a way to store the energy. So I have dedicated my efforts now on developing technologies that can both store the energy, but also as a utility is trying to figure out how to onboard more renewable. How do we capture these energy sources in a robust way for societies, not just for vehicles? And so our company is now on the mission of bringing our next energy, or electrification, to the masses. And I met Hazrat Khalifatul Masih in 2007, and I presented a vehicle that I'd worked on during my work at Ford. And I asked him what he thought. And he said that you're working on technology for the elite. Why don't you work on something for the masses? And since that time, I have been in pursuit of trying to define what that technology roadmap is. And that is our prayer, that we can enable this technology for our next energy, or One, that it brings electrification to the global audience, including Sub-Saharan Africa, Indonesia, South Asia, and all of the other parts of the world. That if you look on the world map at night, you'll see there are dark areas of the world that don't yet have the same access to electricity that the rest of the world does. And so we're trying to evolve that. So my humble message as I conclude to the youth that are on this call is, as I listen to your projects and your inspiring vision of technology, is to realize that you are part of a community that has at the foundation an ilham, a revelation that was expressed in Tazkara by the Promised Messiah alayhi salam, which is that I will grant thy a community that will excel all others. And that means that you have somewhat the access for inspiration, vision, and then with hard work, prayer, and persistence, that you are able to then move that vision forward into beneficial technologies that are not self-serving. This isn't about wealth creation for individuals. This is about the enabling the future in a broader way that brings technology to the masses, which is also, as the scientific pursuit of Dr. Abdus Salam and thinking about the theories of the grand unification of forces, was also a pursuit that could help people unlock the next level of ideas. And that's what scientific journeys and why intellectual property is patented, is we are all creating stair steps on the way through the knowledge curve that will eventually lead us to greater access and greater deployment of technologies that more people can gain access to and that can benefit mankind. So I appreciate the opportunity to present to you today, and I humbly submit that your pursuit should be coupled with mentorship find those mentors that can help in guiding you, but also find the hands-on projects that can inspire you and others around you to continue to pursue your technology dreams, and don't give up. My recent interview, someone asked me for 5 words that described my personality, and I had to think about that. And the words that I chose were that disruption requires creativity and persistence. You can't get to disruption without, first of all, thinking about something new, but then you also have to persist. You have to keep working. And that's my closing remark to you, and Jazakumullah for the opportunity to present.
Thank you, Dr. Majib Jasab. I really appreciate for your time. And I think we'll go directly now to our QA session. I'll request Nabil Saab to kindly allow the students.
Yes, so I think a few students have joined who have asked questions, submitted questions online on the website. And I think if other students who are listening wish to ask any questions on the panel, we have the astronaut Mark, Majib Ejaz, and the professor of chemistry, Eric from Alberta. So these 3 are on the panel for the Q&A session. Anybody has any question, they can submit it online, abdussalamsciencefair.com. There's a button, submit your question. The question, as soon as it's vetted and it's selected, you will receive an email, and then you can join this QA session. So we have a few questions, so we can start, Dr. Saab.
Okay, so the first question is from Sobia Ahmed. Can we allow her to ask question directly?
Yes, she must have joined. I think, yes, she has joined. So Sobia, you can unmute yourself and ask your question.
Assalamu alaikum.
Welcome.
My question today is, why did Dr. Abdus Salam spend his Nobel Prize?
Okay, I think that Majib Jasab perhaps can answer this.
As my recollection is that he donated his prize, and maybe someone can confirm that. But I think that he humbly wanted to reflect his value system, which is that the monetary prize was not something that should be personally hoarded, but rather given as a gift and the way of service to others.
Okay, Jazakallah.
Next question is from Zayan Ahmed. So he is asking these questions
He's
to
joined.
any of the.
Yeah.
Okay.
So my question is there a rocket that would not get super hot when returning to Earth, so that it would lower fuel need for the rocket trip? And you might be confused because if when you return with a rocket, you go above 1500 degrees Celsius, which melts the metal, which falls into the ocean. But is there a metal that is the same way as hard metals that are on spaceships, but can withstand the heat, so that you would need to use less metal, therefore letting us use less fuel? Well, this is my question to Mr. Mark.
Well, thank you very much for that very good question. You're right. When a space vehicle returns to Earth, such as in the case of the space shuttle, as it re-enters Earth and meets the atmosphere, there's a great deal of heating up. And in fact, if you remember the space shuttle, it looks like a little bit of like an airplane, but with short wings. The forward edges of the wings and the nose of the space vehicle can get over 2000 degrees as the heating up occurs as it re-enters the atmosphere. And what NASA decided to do in designing the shuttle was, because there was no metal that really could handle that kind of temperature, is they created the special tiles that cover the entire body, and special other material, which is called carbon-carbon material, that can withstand those very high temperatures. And it is because of those special tiles and that special material on the leading edges of the wings and on the nose of the vehicle that the space shuttle is able to return safely to Earth despite the very high temperatures. Unfortunately, in one case, and this was a tragedy, it was Space Shuttle Columbia, while it was launching up into space, some of the tiles were damaged. And as it returned to Earth, unfortunately, the metal behind the tiles, which was aluminum, could not withstand the heat of reentry and unfortunately resulted in a tragedy. So it is very important to have that protection if you're going to bring the vehicle back to Earth. Thank you.
Thank you, Mark. There's another question by Zayan Ahmed. Actually, no, sorry. Actually, if I allow Fiza first, Fiza Hashmit, because that question is related to Mark again. So if Fiza can ask question first, then Zayan can answer.
Okay. Assalamualaikum. My question is for Mr. Mark Garnu. It is, what was your favorite and least favorite experience that happened to you in space?
Well, thank you very much for that question. My most favorite experience in space was simply looking out the window at Earth because of the unique vantage point, the unique perspective of seeing our planet. When you're, in my case, I was in the space shuttle. I was not far enough away to see all of the Earth, but very, very high up and able to see about 1,500 kilometers in front of me and to see the curvature of the Earth. And it is totally fascinating to look down at Earth, at our planet, as you fly over all of the different countries. And it only takes you 90 minutes to go around the Earth. So you go around the Earth 16 times every day. And although we had a lot of work to keep us busy, whenever we were given some free time, we were always, all of us, looking out the window because it's so interesting to look down at Canada or at any other country that we flew over. That was the most pleasant part. I would say the least pleasant part, and there weren't very many of them, is that some astronauts, when they're up in space, get a bit of a backache. And the backache occurs because in the absence of the effect of gravity, you actually grow in space. I was about 5 centimeters taller in space, only while I was in space, because my spine was unloaded. In other words, the discs between the vertebrae are no longer compressed by gravity here on Earth, and you actually stretch a little bit. And that can cause a bit of a backache, but that was a very minor unpleasantness, and certainly it really wasn't important when you think that I had the extraordinary privilege of going into space. Thank you.
Thank you. Next question is from Zayan. This I would appreciate if all three panelists, they can briefly respond to this question.
Okay, Assalamualaikum.
Walaikum salam.
I have a question for Mark Garnu.
Okay, I thought that it is a general question. Okay.
So what is it like in the future? Like, does science get harder in the future, and what is it like?
Well, I think that's a question that the other panelists may want to answer. So I'm going to turn to Mujib and Eric if they want to answer that.
Correct. I think both of them can answer briefly to this question.
Yeah, I think, thank you for the question. Does science get harder? I think what it is that we unlock science as time goes on. If you go back 100 years, there was a very interesting situation with the automobile industry because automobiles were powered by steam, electricity. There were electric vehicles back in the early 1900s and also gasoline. And it wasn't until the merger of scientific discovery around technologies that eventually petroleum-based gasoline vehicles took off. And now we're rediscovering that we can compete and do better with battery technology. So it's like, as we go, it's like a story in a book, and you keep turning a page. And as you turn the page and you read as mankind keeps inventing, it turns you to the next page, and you get to a little higher level of understanding, and it brings about technologies that could eventually unlock the mysteries where we can get greater energy, we can levitate trains, we can power our vehicles with maybe something that you never refuel for an entire year. And as that goes on, those small discoveries lead to big, big discoveries. And that's the beauty of how our Creator has given and endowed man and women with the knowledge to then unlock the secrets that are coming in the future.
Eric, if you could add.
Yeah, so I agree completely with Dr. Ijaz that the challenges seem, especially when you look back through the past, a lot more daunting. You know, how can we have a battery technology for your cars to go 2,000 kilometers, you know, in a perfect world, you know, this kind of situation. But also the tools we have and the knowledge has grown. So the steps we're making is the same, pretty much as in the past in the sense, just that now it looks a bit more daunting or more scary because there's so much more knowledge out there. But maybe I can comment also on what it's like to be a student progressing through learning about science, because it actually, in terms of, you know, you might be taking, you know, you went through already a very, you know, big challenge, right? To science fair, to think of a problem to solve and be creative. And as you go further and further along, those problems might be more complicated. You might actually have to have collaborations to help you. But your skills have improved as well over time. So actually the challenge is about the same, whether you're in grade 5 or whether you're like me, you know, 45 years old and a professor. So the challenge is always there. But again, it's being persistent, being positive, and being creative. That's what you need to be successful.
Thank you very much. Our last question is from Fateh Zadi. Fateh Zirman Hadi.
Assalamu alaikum.
Welcome.
My question is for the astronaut Mark Garneau, and it is, how did you become an astronaut and what did you do to get here?
Well, thank you very much. That's a question that I'm often asked because a lot of young people want to become astronauts one day. And so in my case, because I was the first, it was at the beginning of the space program for astronauts in Canada. And Canada was looking for some astronauts, and they basically announced in the newspapers and on the radio that Canada was looking for astronauts, and anybody who thought they could be an astronaut could apply. And I thought this would be an incredible adventure to have the opportunity to go and fly in space and to see Earth from above. And so I didn't really think I would be chosen, but I thought if I don't try, I'll never know. And that's a good lesson in life. If you think you might want to do something, but you're not sure you can do it, I would still say you might want to try it because sometimes you're going to surprise yourself. And so I was lucky. I was chosen. And so I was one of the 6 first Canadian astronauts, and my dream came true. But if I hadn't written in and said I want to become an astronaut, it would never have happened. So don't hesitate sometimes when you want to do something and you think you might be able to do it. Don't say, no, I won't do it because I won't be chosen. Go ahead and do it anyway. It doesn't matter if it doesn't work out. There'll be other opportunities.
Thank you very much. Actually, there are more questions, but due to the limitation of time, we will stop at this point, and we'll try to have some other sessions where we'll invite these guests to answer our students for their in this inquisitive mind, what they have in their mind. Thank you very much for the panel. And now I'll request our National President, respected Lal Khan Malik Sahib, who is the Amir Jamaat Canada, to give his concluding remarks.
Bismillah ar-Rahman ar-Rahim, in the name of Allah, the Gracious, the Merciful. Honorable Mark Garneau, respected Professor Eric Rivard, respected Mujib Ejaz, respected guests, ladies and gentlemen, and very dear students. Assalamu alaikum wa rahmatullahi wa barakatuh. May peace and blessings of God be upon you all. I want to thank you for joining the virtual award ceremony of the 14th annual Abdus Salam Science Fair. I thank all the dignitaries for taking out the time from their busy schedules to join us today. This National Science Fair is held to commemorate the well-recognized contributions of Nobel laureate Dr. Abdus Salam towards science, as well as to promote and inculcate scientific thinking and methodology among the students of grades 5 to 12. Moreover, it provides a platform for the students to exhibit their skills, ideas, aspirations, and they also win prizes. Dr. Abdus Salam was the first Pakistani to win the Nobel Prize in 1979 for his contribution to the electroweak unification theory in physics. Dr. Salam made a number of very important contributions to different fields of physics and maths. Apart from his scientific contributions, he played a big role in encouraging the youth from his native Pakistan, as well as other developing countries of the world, to pursue and excel in science. Dr. Salam stands as a giant in his contribution to science and to the development of science in third world countries. Ladies and gentlemen, the importance and central role of science cannot be overemphasized. Science generates solutions for everyday life and helps us answer the great mysteries of the universe. Science is one of the most important channels of knowledge and has a variety of functions for the benefit of our society, including creation of new knowledge, improving education, and increasing the quality of our lives. Science must respond to societal needs and global challenges. In turn, we as human beings must respond accordingly to scientific direction. For this purpose, public understanding and engagement with science are essential to equip citizens to make informed personal and professional choices. Science has a very direct impact on our ways of life, as governments make a multitude of decisions based on quality scientific information on issues such as health and agriculture. Further, world organizations consider scientific implications upon a variety of challenges facing the world today. Deep understanding of science allowed us to tackle one of the most pressing issues today of COVID-19. This was done by a plethora of professionals coming together to understand the complexities of the pandemic and in turn developing vaccines to combat it. To resolve the biggest challenges today, governments and citizens alike must understand the language of science and become scientifically literate. On the other hand, scientists must understand the problems policymakers face. They must endeavor to make the results of their research relevant and comprehensible to society. Ladies and gentlemen, at this point, I would like to extend my heartiest congratulations to the winning students. My sincere thanks once again to all the respected dignitaries and guests for joining us today. Let me say that your participation is of great encouragement to the students as well as the organizers. Thank you very much.
Jazakallah, respected Mr. At the end, I would give my vote of thanks. Auzu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. I seek refuge in Allah from the accursed Satan. In the name of Allah, the most gracious, the merciful. Respected Amir Sahib, distinguished and honorable guests, our young scientists, ladies and gentlemen, Assalamu alaikum wa rahmatullahi wa barakatuhu. Peace and blessings of Allah be upon you. On behalf of Ahmadiyya Muslim Jamaat, I would like to express my deep sense of gratitude and heartfelt thanks for joining at the 14th annual Abdus Salam Science Fair. This is indeed a difficult period in human history with numerous challenges that are being faced on almost all fronts. At the same time, it has provided many opportunities to connect and organize events in a more innovative manner. As such, the 14th Abdus Salam Science Fair is a unique in the sense that we have for the second time participation in the science fair from across the country, thus reflecting a true national color in the science fair. I want to congratulate and express my heartfelt thanks to all the educational secretaries across Canada for all chapters for their contributions to make the science fair very successful. I would like to express my profound gratitude to the Right Honorable Justin Trudeau, the Prime Minister of Canada, for his special message to participants of the Abdus Salam Science Fair. Similarly, many other dignitaries, premiers, and also the Speaker of the House of Commons and other our distinguished guests, they send messages. And I'm very grateful for them. My very special thanks to our honored guests who took time off from their very busy schedule to join us today in the live ceremony at the Abdus Salam Science Fair. I would like to extend my sincere thanks to respected Lal Khan Malik Sahib, the President of the Ahmadiyya Muslim Jamaat, for his continuous support for the Abdus Salam Science Fair. My special thanks to all participants, visitors of the Science Fair, all students from across Canada, for spending significant amount of time in order to prepare their projects and presentations. I'm grateful to our youth organizations, Ladies Association, especially all volunteers who spent countless hours in the preparation and execution of the science fair, all the judges, GS office, and all others who supported and helped in various ways. A few individuals in the organization team had worked beyond the call of duty. Among these are Dr. Amir Minaz Khan Sahib, the coordinator. Similarly, Nabil Rana Sahib, Zafar Nadeem Sahib, Amjad Sahib, and Shahid Mirza Sahib, Faraz Qureshi Sahib, and many, many others who have worked relentlessly in this, in the preparation and execution of the science fair. I have so many names, I will omit that, but I hope and pray that Allah Ta'ala will bless them, and I request you to pray for them as well. I also like to extend our special thanks to our panel members, Mark Garneau, our first Canadian who went into space, Dr. Eric Rivard, who's a professor of chemistry from Alberta, my own field, Greg Dick, Senior Director of Public Engagement. He was supposed to join, but he could not join. And finally, our keynote speaker, respected Mujib Ijaz Sahib, who joined us from the USA, despite his very busy schedule and short notice. I'm truly grateful to you, Mujib Sahib. By the grace of Allah Ta'ala, many Jamaats, they have done outstanding work. So I'll only mention top 3 Jamaats, Brampton West, Vaughan, and Calgary. They have outstanding work in having the number of projects from the participants. I'm sure that everyone has enjoyed today and hope next year will come with even larger number and with more new ideas. This annual science fair is organized with the following objectives. First objective is to encourage our students to choose science as their field of study. Secondly, to exhibit their ideas in the form of projects and scientific displays. Thirdly, to learn and sharpen their knowledge by exchanging ideas with other students. And lastly, but not least, above all, they should celebrate the achievement of Professor Abdus Salam Sahib, who was the first Nobel laureate from the Muslims, among the Muslims, and he got the Nobel Prize in 1979. It was the desire of Hazrat Khalifatul Masih III Rahimahullah Ta'ala that we should have 100 Ahmadis who would become like Dr. Abdus Salam. Department of Talim, which is Education Department of Jamaat Ahmadiyya Canada, is therefore trying to provide forums that will enable our students to learn science, to exchange ideas, to explore their imagination, and become future Abdus Salam, inshallah. Professor Dr. Abdus Salam was a gifted Ahmadi Muslim scientist who loved Holy Quran and once said that his theory is based on the Holy Quran. I will encourage my young scientists to take full advantage of what Canada offers us in the scientific field and realize our full potential. Jazakumullah ta'ala, Asimullah. Once again, I thank you all for spending this afternoon with us. May Allah ta'ala bless you. Ameen. Jazakumullah. Respected Amir Sahib, I will request you to kindly lead us in silent prayer. And for the honored guest, you can join us in whatever way you feel comfortable in the prayer.
Alaikum warahmatullah. Please join me in the silent prayer that Allah may bless this event and Allah may make the good impact of this event last long. Join me in the silent prayer. Ameen. Allahumma ameen. Jazakumullah.
जज़ाकुल्लाह। बहुत बहुत शुक्रिया भी साहब आपके ज्वाइन करने का। अस्सलाम वालेकुम।
Nabil Rana Sahib should announce the ending of the event. Rana Sahib.
Assalamu alaikum. Yes, so we conclude and we adjourn till next year. Inshallah, we will have in-person science fair where we can interact and see these projects in real. So inshallah. So until then, assalamu alaikum wa rahmatullahi wa barakatuh.
वालेकुम अस्सलाम
वालेकुम अस्सलाम व रहमतुल्लाहि व बरकातुहू। वालेकुम अस्सलाम व रहमतुल्लाहि। वालेकुम।
Assalamu alaikum.
वालेकुम अस्सलाम। You are